honor to open the second day of our international conference, and the first session today is entitled Climate, Nature and Man in the Anthropocene. Anthropocene means a geological era, and well, the name is unofficial at the moment, but there is no doubt that man has an influence on the climate and natural resources, natural ecosystems, so that man has a global influence, and the session will focus on these issues. We have only 20 minutes per each lecture, so I'd like to introduce Professor Szymon Malinowski, the director of the Institute of Geophysics at the Faculty of Physics, University of Warsaw, eminent researcher, scientist, researcher of climate phenomena, great expert on science who disseminates popular knowledge on science as well. He received an award of the Foundation for Science named after Professor Grabski. The floor is yours, Professor. Good morning, ladies and gentlemen. Thank you very much. Thank you for this kind introduction, for inviting me here and giving me the possibility to talk to participants about climate crisis. I was asked to have a presentation which will be easy to be interpreted into English, so there are slides in English, but I will speak in Polish. What you see in here is a unique photo, an image from Deep Space Climate Observatory, and it is a satellite in Lagrange point between the Earth and the Sun, 1.5 million kilometers away from our planet. And here you can see a light side of the Earth and of the Moon, as it is seen from the satellite. You may notice here that these two bodies look like that. They are both immersed in the same stream of solar energy, but at first glance you can see that conditions on their surface and what is happening there are dramatically different, and what we can see here looks like a desert, and the same albedo, so ability to reflect solar radiation, is the same. On the Earth there is white, blue, green, and what is on the Moon? What is blue and white? Blue and white is water. Water in various conditions of fragmentation. In oceans it is blue, dark. In the atmosphere and on the surface of the land, very often it is white. So there are small droplets of water and crystals of snow. So due to that, our planet is lighter because it reflects more solar radiation than the Moon. What we cannot see is the atmosphere. It is this thin layer due to which the conditions on the surface of the Earth are totally different than on the surface of the Moon. I don't have time to ask difficult questions that I usually ask during presentations like that. So what's the thickness of the atmosphere? Let me put it like that. 10 meters. 10 meters, if we condense it to the density of water, if you compare it with the amount of water on our planet, the ocean covers 3/4 of the globe, and it has 3 or 4 kilometers of depth. The atmosphere and the ocean are liquids which can redistribute the energy during their tides and flows. And that is what is different when you compare the Earth from the Moon. Living conditions, the climate on the surface of both celestial bodies are dramatically different, despite of the fact that they are supplied by the same solar energy. Generally speaking, our planet operates like that, like every planet which have neglected heat sources inside them, that it is powered by high temperature and high quality solar energy. And some of the energy is absorbed, the planet is heated up, and it radiates the energy out into the space. And the energy balance is connected with the energy content in the climate. And the temperature is the measure of internal energy. When the balance is positive, the temperature goes up. When the balance of energy is negative, the temperature drops. In this slide, you see an image, quite a new image, but the balances have been carried out for a long time and they usually look the same. An energy balance on the surface of our planet per square meter of the planet. You have 340 watts of solar energy, less than half is absorbed, heats up the surface of the Earth, and then it is emitted as infrared radiation, and a large amount of that is stopped by some elements of the atmosphere, so gases with 3 atoms in their particles or more. The atmosphere is heated up and emits radiation into the space. There are additional mechanisms of heating up the surface of the Earth, evaporation and phase transformations. There is no time to discuss it at length. What I wanted to focus on is that observations from the space and observation of the contents of energy in our climate system show very clearly that there is a rapidly growing imbalance. So 0.7 watt per square meter, that's the imbalance. And in the ocean, which is like a container of energy for the climate system, we can observe systematically that energy is growing. The atmosphere is just a small fraction, but we see growing temperatures next to the surface of the Earth as well. And if we look at the data, paleoclimatic data, if we reconstruct temperatures changing on the surface of the planet on the basis of the ocean sediments and various observations of traces of climate changes on the surface of the Earth, we'll see a line like that, a curve which shows what has been happening with the climate for the last 2,000 years. Under the influence, and I will discuss it in a moment, under Milankovitch's forcings, climate started to go towards another ice age. And at a certain point, this trend was abruptly reversed. And now we are observing a very fast, geologically speaking, fast temperature growth. In order to understand that, we need to have a closer look at the climate system. If we assume, in line with our knowledge, that the average temperature depends on the energy balance, looking at the climate system, so everything which is on the Earth's surface, we can differentiate between two kinds of dependencies, which may have an impact on the energy balance. One of them are events from outside of the climate system, which are called forcings, and the other one are responses of a complicated climate system to these forces, which are feedbacks. And if we have any climate changes, usually they are caused by events from outside the climate systems, like orbital changes or changes in the sun activity, changes in the volcanoes activity or volcanoes eruptions, because what is happening underneath, deeply in the Earth, apart from volcano eruptions, many things are happening there. So we also may have another kind of activity or another kind of forcing, which hasn't ever happened before in the geological history of the planet, which has still a tremendous impact on the composition of the atmosphere. It is anthropogenic forcing. And in individual years, we incinerate coal, which was accumulated in rocks for millions of years, and we incinerate it, we combust it at a pace which is so much faster than it had been accumulated. So that is how we have an impact on the composition of the atmosphere, emitting greenhouse gases. We are going to focus on CO2 and feedbacks. Feedbacks also have an impact on energy balance. The more surface covered by ice, the more energy is not absorbed by the system, but it is reflected by the sun. Just examples. The more vapor in the air, the more greenhouse gases. It is a very fast feedback. The ocean, from the perspective of the atmosphere, is almost infinite body of water, so it may be as much as close as Clapeyron law allows for. A bit hotter, more water. Colder, water is condensated, so that's how it goes. And now the most difficult slide in my whole lecture. Well, I could prepare several slides like that. It is just an example. What we have at the top. Let me have a look at the horizontal line, horizontal axis. Here it shows time, since pre-human civilization times till 800,000 years before our times. 300,000 years ago, there are remnants which were identified as Homo sapiens for the first time, so that we see the time scale in the right way. 300,000 years ago. At the top, in the vertical axis, we have temperature variations from the period before the industrial epoch. And you have two lines here. One line is the line of reconstruction, so paleoclimatic data, so specifying temperature changes on the globe on the basis of what the changes left on the surface of the Earth. It is Roxy-based reconstruction with uncertainty range. The red line is the line which was created in the following way. We cannot check several Earths. There is one. So we create virtual planets, knowing laws of physics, knowing about forcings, feedbacks written in the language of mathematics, and we have virtual realities in which we can research and examine the response of our climate system to various forcings, or we can check feedbacks which occur there. And what is at the bottom of the slide is the results, the red line, and what is described in detail at the bottom is the result of an exercise like that. We take Milankovitch cycles for forcings. Milankovitch cycles are fluctuations over here. You can barely see them. And we check how a complex climate system responds to forcings. We investigate individual feedbacks. At the vertical axis are changes in the energy balance of the planet. Forcings led to a cascade of feedbacks, like icelands being created, reflecting solar radiation, more dust in the atmosphere. You can test it in ice cores. Then solution of oxygen, CO2 in the ocean, because in colder waters it is dissolved much better. The red line is a feedback connected with changes of CO2 concentration in ice ages, but the blue line and the red line at the top are total radiation forcings and total temperature change. So if we have a look at CO2 concentrations in the atmosphere, this long-living greenhouse gas that changes during ice ages were a feedback responsible or caused by external forcings in the form of Milankovitch cycles. Here you can see anthropogenic forcings. So you may notice, think about your date of birth and place it on the vertical line and find what were the forcings at the moment of your birth, then during your primary school years, then during your academic university years. So that's what's been happening in the atmosphere. When you have virtual realities like that, you may have various exercises, various tests, how the temperature of the globe would have been changing if it wasn't for forcings. It is an example of an exercise like that. Unfortunately, there is no time to give you more details about that. There is a drawing here which shows to you that CO2 concentration in the atmosphere started to grow quite a long time ago, not necessarily when we started fossil fuel burning. Before that, when agriculture developed and we started to replace rich ecosystems, including a lot of carbon, with poor ecosystems, which are used to produce food for us, the carbon which used to be in the ecosystem originally, appeared in the form of CO2 after oxidation in the atmosphere. So if you look at the period of the last 170 years, that's the part of the graph here, we can see that emissions, land use, so changes in land use, so in a nutshell, from depletion of life on our planet for a long time were maintained at a stable level. Then they were growing dramatically because they were fossil fuel emissions. So let us have a short experiment. Let us assume that the total chemical energy encapsulated in a living matter which is present on the surface of the Earth is used only for feeding people. This energy, chemical energy, in zeta joules in the last 2,000 years is shown here at this vertical line. And a simple calculation. Let us define the time scale for how long this chemical energy, life, which has been developing in the long run, is sufficient for human beings. So we take this chemical energy, we divide it by the number of people, and we divide by annual demand, metabolic demand of a human being, and then we receive a time perspective. This time perspective is shown here. Here we can see how the climate crisis is combined with the crisis of biodiversity and how it undermines our basic livelihood elements. You can see a graph here which shows it differently. It shows that we are the main dominator on the surface of the Earth. On the vertical line, there is a biomass, or the mass of all things manufactured by human beings. You can see a timescale as well, how the dynamic exponential growth is happening. Exponential means that there is doubling after some time. So it is happening really very fast. If it is by 3%, it will double within 24 years. And there is another aspect of this topic that I haven't mentioned so far, that our system, the climate system, includes various amounts of carbon and may influence the reflection of solar radiation when the conditions will change rapidly. These are called tipping points in the climate system. And as we know more and more about this climate system, and we can see that these points, which may lead to rapid release of carbon in frozen permafrost, it may lead to fast destruction of the Amazon forest. It may change redistribution of the heat on the surface of the globe. It may lead to destabilization of Iceland. And these events are closer than we have thought so far. I'm almost finishing my presentation, but here you can see 65 millions of climate changes. At the top, there are temperatures. At the bottom, there is logarithmic drawing, and there is concentration of CO2 in the atmosphere. 50 million years ago, there was this era which led to a slow drop of CO2 in the atmosphere and slow cooling of the atmosphere. The whole natural world that has evolved during the last millions of years around us is the world of cold planet for the last several million years, or perhaps a few million years. So it was between ice ages, more or less. We have an opportunity to change this situation within. We can change this situation within the next years. So historically speaking, it will be a shorter period than the period of existence of the Polish Academy of Arts and Sciences. In the past, the Earth, in the last several million of years, or definitely during the last 800,000 years, the Earth was between glacials, interglacials, due to forcings, and we added so much CO2 to the atmosphere that we pushed it out its regular scope. And we have a situation like 4 or 7 million years ago, we don't know the specific date, we push it forward all the time. If we cross these tipping points, our planet will go back to the condition from several million years ago. So what is our point? We want to direct it to the current condition so that it is close to the condition in which we know it. Our human system, civilization in the past, was a small addition to the huge Earth system. Now we are the dominant factor, we are a dominator. In so many dimensions, it has happened during the last several years, or a few dozens of years actually. And people notice that, governments notice that. And there is an example of a diagnosis from the last year's report for the UK government, Dasgupta report, with a clear diagnosis, which sounds as follows. We have collectively failed to engage with nature sustainably. We cannot build our civilization in the way taking into account natural conditions. It is a huge threat for future generations. What is the solution? The solution starts with understanding a simple truth, that our economies, our social systems are embedded in nature. It is not in parallel to the nature. And it requires a change of thinking about us on our planet. Thank you very much for your attention. There is time for one question. The speaker has to use the mic. If the speaker is not using the mic, he will not be interpreted. Unfortunately, it won't be interpreted because otherwise it won't. Sorry, the speaker has to use the mic. Thank you. I'm afraid, okay. It is about the forcing 0.7 watt per square meter. I've heard that it is 2.2 watt per square meter, so the situation would be even worse than you have mentioned in your lecture. All right, let me comment on what you have said. We are talking about two things, really, because, well, I agree with what you have said, but there are different definitions of radiation forcings at various heights in different ways. So it is not incongruence, really. I mean, these two calculations that you have mentioned with general data, because basically, yes, this data is in line with satellite observations and observations of the content of heat in the Earth system. And I guess I know the publication you've referred to. You may have an informal conversation about that. Let me also add that on the basis of sociological research, we can see that 1/3 of people on the Earth believe that there is a climate change. Out of 1/3 of the population, a small fraction examines the climate changes. So what you are discussing today is not accepted by like 2/3 of the population of the Earth. So let us imagine that 2/3 of the people in this room do not believe that. Just imagine that. All right. The most important thing is to understand how exponential function works. So doubling every 3 years. So let's say, so if we depleted 20% of a certain resource is a certain time frame, after one doubling of this number will deplete 40. After 2 doublings will deplete 80% of the same resource. So that's how exponential growth works. That's fundamental maths. So we can't teach maths properly, I guess. That's the problem.
Dziękuję. Następny wykład pod tytułem Trudna droga.
So the next lecture will be given by Professor Jan Kozłowski, Professor Emeritus from Institute of Environmental Sciences, Faculty of Biology, Jagiellonian University, Kraków, The Difficult Road to Decarbonizing the Economy. So the professor is professor's scientific and research activity was awarded with the prize from the Foundation of the Polish Science, the so-called Polish Nobel.
Let's see. I prepared the presentation in Polish and English. Is there anybody here not understanding Polish? Please raise hand. No. So please give presentation in Polish. Proszę o prezentację po polsku. Z prezentacji profesora Malinowskiego są dwie najważniejsze informacje.
So we had two major pieces of information in the previous presentation. So the climate is evolving towards a warmer climate, and these are greenhouse gases which are responsible for that. And in response to the question that was asked a moment ago, when we hear about the greenhouse effect, well, the response to that was different in the past, and it's different now. In the past, that would meet with denial or disbelief that the main culprit is a man or was a man. Well, obviously, most people were indifferent, and politicians, they disregarded these issues, and the warnings of the impending disaster were actually the size of fonts on this slide. When I'm telling about the warning of impending disaster, taking preventing actions, well, that gives you the message how important that issue was in the eyes of some politicians, some people. Well, now I think that things have changed. There is a small groups of disbelievers, those who deny that is sustained by the fossil fuel lobby and disinformation sown by the Putin regime. And there is this disbelief that the main culprit is a man, and most people basically are not concerned and they continue with their life. However, we commonly hear this warning about the impending disaster, and I think it's quite common that preventive actions are taken. Well, quite often we hear that nothing is done about it. And I think this is not true. A lot is being done. However, it is not enough to prevent a disaster. Ladies and gentlemen, these emissions are beyond our understanding. Can you imagine that size of emissions? Just if we look at the carbon which is emitted every year, let's take out pure coal out of it and let's load it on the coal carriage, and such a train would be that long that it would that train would be that long that it would go around the equator 37.4 times. And there are also some negative outcomes, negative effects of that. So a major size ends up in soil, but a major part remains in the atmosphere. So, ladies and gentlemen, that cloud that you can see on this slide, this cloud which is expanding, well, it is showing how the emission was expanding. And here we have the main culprits. So these are China, the USA, the EU, and then India, Japan, and Russia. And here I listed and compared, well, emissions and the GDP. It is scaled in such a way that the total of these graphs here for GDP and emission corresponds to the width of this axis, the size of emissions. So you can see that China emits much above its GDP, but bear in mind that we exported a major part of our industry to China. The EU and the UK, well, they are not major emitters when compared to the GDP, but actually we transferred these emissions to China. Similarly, note that India and Russia have been emitting a lot when compared to the GDP. And in the light of the crisis that we have right now, note the very insignificant GDP of Russia. Now, if we have a fair look at emissions, and let's analyze emissions per capita. So China emits as much as the EU, and the United States, Saudi Arabia, huge emissions. Now, if we look here at the cumulative emissions, so historically, the main culprits are the United States and the EU. And actually, it is a good coincidence that the two major economic organisms are the most responsible for all that, and it is also the responsibility to endeavor to prevent this disaster. So, ladies and gentlemen, there are some concepts such as geotechnical methods of temperature reduction. So, for example, place of reflective films in the upper layers of the atmosphere, SO2 atomization that would work reversely to the CO2, or let's fertilize oceans with iron. So, I beg you, we should oppose this idea with all force. Well, like placing reflective films, well, that's all very well, but how can we remove them? But if we atomize something that will be falling on us in the form of a rain, if we fertilize oceans with iron, that could help for a little while, but then there will be oxygen free zones in oceans. So only safe decarbonization of the economy and of the atmosphere is the way. Is it economically feasible to decarbonize the economy? The International Energy Agency calculated the cost of that at 100 trillion US dollars. That's the global GDP. And if we are to do that by 2050, that is only or as much as 3.57% of the world's GDP. And this is not the money that is the problem. There is this need for a major overhaul of the world's finances, the need for reliable and honest monitoring. And technically, that is not easy because all we have, these are rough estimations, and the need for mechanisms to force decarbonization throughout the world. So I would call it forced decarbonization, and then we need to offer massive support for countries with low GDP. So far, any arrangements that have been made so far are not being delivered or are delivered in their fraction only. So the EU is the leader here, but the United States has entered the race recently. And it seems that China is doing a lot. So there is hope, certain hope that we may be successful. Because these three economic organisms are responsible roughly for 50% of all emissions. But it is not going to be easy. What you can see on this slide we have emissions of the year 2000. That is a growth of emissions caused by the growth of population. Then we have the growth of emissions caused by growing average GDP globally, and richer countries emit more. Then we have a growth in the CO2 per energy unit consumption. And here we have a reduction of energy consumption by economy. So we have this huge growth of emissions between the year 2000 and 2010. Following up on that, so that is population growth, that is GDP per capita growing, and this is a drop because we produce energy in a less emission prone environment and GDP to energy. So again, we have a growth. So that is an incredibly difficult situation. Now, let us analyze the situation by sector. So I'm referring to Bill Gates' book because he has excellent advisors. Note that a lot of these emissions, well, that's 7% globally and 46% in Poland, that's electricity production. And we also must be aware that decarbonization will drastically increase electricity consumption. So I think this is a sure fact. So what is the key thing here is the energy transformation. So therefore, transformation of electrical energy production. So this yellow circle here, yellow dot here above, tells us that we're on the right track, but we're too slow. Red tells us that this is a wrong direction, or it indicates stagnation. And then we don't have one for going in the right direction and at a good pace. So if we look at the development of photovoltaic farms and wind-generated energy, this is where we are now, and by the end of the decade, we should arrive at zero emissions in 2050. So no, this difference is major. We have a very rapid growth of these two sectors, but still we are far, far away from that goal. One would think that accelerated development of nuclear energy generation would be a solution here. So that's the difference between what we have and 2030. But this difference is not huge, but in the past 3 decades, well, that's unfortunately the influence of so-called Greens, nuclear power generation wasn't developing. So all these forces, all these activities that could speed up that power generation were dormant. So here, the best idea would be to retrofit, revitalize those nuclear plants which are being closed down or have been closed down, but because of this constant concern about nuclear power plants, well, not much is said about it. We are very hopeful as to small nuclear power plants. These are modular nuclear power plants. They are mostly manufactured in regular plants. So we'll see how that works, but we're very hopeful about it. Unfortunately, my slides stopped. Slideshow stopped. Okay, here we are. And then we have this energy transition. It's not only about new sources, but it's about network reconstruction and energy storage and the need to maintain reserve energy sources. With the transitional role played by the natural gas gradually replaced by hydrogen. And here, a major mistake was made because natural gas was treated as a replacement or equivalent to coal, but it should be treated as a reserve resource only. And now we're in trouble. The whole EU is in trouble, Poland's in trouble. We hear about it every day. Decarbonization of transportation, so we're quite optimistic about that. So we have green dots here. So we'll have only battery-driven, battery electric cars. Then airplanes, well, we'll see, we're going to see about it, trains, etc. That will be solved, but at a later stage. Decarbonization of industry. Unfortunately, a large red dot because we lack mature technologies. Obviously, hydrogen is going to play a major role here, but unfortunately, that is far-fetched. Well, that is future for us. And as for decarbonization of heating and cooling, well, heat pumps, well, this is an up-and-coming technology, but not suitable for cities, for urban areas. So, like municipal heating, system-based heatings, well, what we have in Krakow, if communities, societies accepted these modular nuclear power plants in their neighborhood, then we would have electrical, local municipal heating. But fear of nuclear power generation is too big, and then we would need to reduce emissions of other gases, mainly methane, from landfills, from fields, primarily from rice fields, from animal breeding. It is absolutely necessary to limit ruminant farming, etc. I believe, etc., etc. I believe there are some new methods for that. So, ladies and gentlemen, if emission of methane formation and capture of methane from mass cultures is not prevented. Well, our future looks bleak, but luckily methane is now being tracked and followed closely. And also, it is necessary to take a certain amount of CO2 out of circulation. Well, about 10 to 20% of emissions cannot be eliminated, or can be eliminated, but too late to halt the temperature rise. It could be done through some natural processes, by binding by minerals. So, for example,
tej reakcji. Więc tu wydaje się, że można by to przyspieszyć.
peridotite. And also some ideas are to add basalt rock, aggregate of basalt rock to soil. Additional another idea would be to store CO2 by injecting water saturated with carbon dioxide into basalt underneath the ocean. Why is that method excellent? Because it is is bound there, and there is another option to remove CO2 from the atmosphere by natural forces. So there are emissions which represent about 10% of natural carbon turnover in terrestrial ecosystems, and it is possible to increase the CO2 absorption potential by forests by increasing the area of the forests, giving back to nature some of the forests, so stop their exploitation and introduce some changes in forestry and agricultural practices. Well, unfortunately, the net forest area is declining globally. It is growing in Asia and in Europe, but it is declining in Africa, in Latin America, and globally as well. Well, growths are lower than declines. And also note that these declines are reported for tropical forests because of biodiversity. These forests are huge CO2 storages. Well, and also in Asia, these tropical forests are replaced with plantations. And here, ladies and gentlemen, the most recent presentation of data for 3 regions was this as follows. This blue part represents forests which are removed for domestic demand, and the brown one for export demand. So you can compare Africa, Latin America, and Asia. So in Asia, the export demand is the largest. And what it means is that, first of all, we need to accelerate the process of population growth in these areas in Latin and to reduce the number of population in these countries, which is not easy because that is mostly Christian, Catholic and Muslim population. And well, unfortunately, in Latin America, deforestation is caused by introduction of grazing land for animals, and so what we can do about it is to reduce consumption of meat, mostly beef. But in Asia, deforestation is caused by mainly oil palm production. absorptions of CO2 by trees, well, that is relatively simple. Well, many forests, they grow spontaneously on abandoned farming soil. And in Poland, for example, forests arise spontaneously about 20,000 hectares per year. So we need to establish plantations to increase timber production. And we need greener fields, greener forests, we need to add greenery. So also bear in mind that by giving back to nature some of the forest will result a positive carbon balance lasting at least several hundred years. So there will be a stronger carbon sequestration in the phase moving towards natural forests, but that will be forced out by the EU unless we have pole exit, which is impeding, I'm afraid. And what is important here, we have increments from much faster timber production, and trees die faster because of hurricanes and drought. And so rotation must be sped up, and if used properly, that could ensure storage in durable wood products for several hundred years. So we need to change of their paradigm. If you have any idea how to convince competent authorities of forests and forestation in Poland, please let me know. So we need to trust the nature. We need to have more succession, less planting. We need to protect the soil and complete abandonment on deep plowing. So can we do that? Can we make it? Is it achievable? Well, it seems that we're late. We're very late. So we are facing the very difficult period of temperature increase of 2 to 3%. So we've been experiencing it so far, and we will. But if we're consequent in our actions and we apply these methods for removing CO2 from the atmosphere, there is a chance of success. I deeply believe it, because otherwise we'll be facing this unimaginable disaster. And one more comment here, the impact of war. We cannot skip this part. You would think that that would delay decarbonization, because the world focuses its attention as well. In the meantime, we'll be burning more coal, but I think that because of the war, we've learned that we need to save energy. We can hear some advice on energy saving. You would think that obvious. You would think that everyone follows such advice, such energy saving tips. Will be also saving food. That is another important element. And now, ladies and gentlemen, we can see long-term effects of reliance on fossil fuels. So I think that the decarbonization after that very short period will accelerate, and that our awareness will be overturned because of the crisis. Ladies and gentlemen, I appeal to you, the difficulties that we have and that we're going to face very soon, well, let's consider them just an introduction to the major difficulties that await us because of the climate change before we'll handle them. Thank you. Well, ladies and gentlemen, unfortunately, if the speaker the mic is not on, may you please ask the speaker to turn on the mic, because the interpreters cannot hear the speaker. May anyone ask the speaker to turn on the mic, please? Unfortunately, the interpreters cannot hear the speaker because the speaker doesn't have his mic on. May you please speak to the mic?
Natomiast spadek w atmosferze to jest być może w ogóle niezauważalny, a jeżeli zauważalny, to będzie z pewnym opóźnieniem. Natomiast szkoda, musiałem tutaj się bardzo ograniczać, bo miałem taki wykres, który pokazywał zahamowany wzrost dwutlenku węgla w atmosferze, związane
ten mikrofon, tak? Oba nie są włączone. Proszę poprosić tych panów operatorów o to.
Jeżeli pan chce powiedzieć, że emisje nie mają wpływu, to szkoda na to czasu.
Przepraszam bardzo, musimy...
Excuse me, I'm afraid we need to move this debate to the break because of the time pressure, and now we'll have the lecture by Professor January Weiner. Professor January Weiner works for the Institute of Environmental Sciences, Faculty of Biology of the Jagiellonian University in Krakow. He will talk about the changing biodiversity formally today. Tomorrow, Professor often publishes in many prestigious scientific journals, and will certainly learn many interesting observations from his lecture.
Możliwość udziału w tym posiedzeniu. Muszę powiedzieć jedną rzecz, że temat...
Thank you very much for inviting me here. Let me just say that the topic I'm going to talk about is very fashionable. There are hundreds of publications, plenty of coverage in the media, popular mass media. There are various publications by various organizations, experts, and so on and so forth. And the deeper we go into this body of publications, the better we know what is unknown. So I'm not sure whether 20 minutes is enough to make even a list of things that we don't know, but let me give it a try. The knowledge of cosmologists, astrophysicists, is hard knowledge. Unlike the knowledge of biologists, we know when the universe appeared, when the solar system appeared, how it happened, but there is a point that life occurred. We don't know when, we don't know how specifically, or what were the first organisms. There are various hypotheses about that. We may guess in a way. We can say 3 or 7 billion years ago, life already was there. We know about evolution, so we may make educated guesses. So we may guess what happened 3.5 or 3.7 billion years ago. We can say that from the moment when life originated on Earth, it was subject to evolution, and diversity of every strain of bacteria is created. A diversity is subject to natural selection. There are various evolutionary strategies. We may guess that at the beginning of life on Earth, resources were plentiful to maintain redox reactions that from a chemical point of view are manifestations of life. So pro-organisms were multiplying, or there were more and more of them. There was a big of biomass and there was growing biodiversity, but to a certain extent it was limited because these things, where am I in my slides? All right, now it's working, good. We also know that at a certain point, pre-bacteria, so pra-bacteria, were able to produce biomass via photosynthesis. So they started to use solar energy to reduce CO2 and produce organic compounds. It was a great benefit, a great gain. These resources which allowed for production of biomass, they were perhaps depleted, but when there was a possibility of supplying with solar energy, everything could accelerate. Another great invention was oxygenic photosynthesis, not sulfur compounds like in the original system with a limited energy potential, but breakdown of a particle of water and energy potential obtained on this basis on the same amount of quantum of solar light was as big that it was possible to have like living on a higher level. It is a certain gain, it is a certain benefit of a certain living strategy. So other strategies could evolve, but biodiversity could start to increase, could be enhanced, because there was more biomass. So like a higher level of energy supply. And the results, well, there were simply side effects as well. The more energy we have, the more polluted environment we have. The first oxygenic organisms polluted the atmosphere with oxygen. At the beginning, the oxygen was absorbed. Perhaps I could show you iron, like oxygenic photoautotrophs. We may guess again, but it was happening like 3 billion years ago. So for hundreds of millions, actually oxygen was absorbed, but minerals that could absorb it were depleted at a certain point, that something else happened. It is called Great Oxidation Event, or an oxidation disaster. So it was dissolved in oceans, oxygen was dissolved in oceans, and for the majority of organisms living then, it was a poison. So a great extinction started. And actually, it was the majority of organisms living on Earth back then. So the first great extinction, 2.5 billion years ago. That's the date for the first great extinction. It was provoked or caused by like inhabitants of the planet. They were oxygenic, photoautotrophs. So that's what happened during the first extinction. There is a suspicion that perhaps, biologically speaking, it was caused, or another extinction was caused 700 million years ago when the Earth became a snowball because the climate was cooled down. Well, we can say it is a fact, but was it because of absorption of oxygen by photoautotrophs? Maybe yes. Maybe it was the second extinction brought about by inhabitants of this planet. Volcanoes provided us with CO2, ice melts, another conundrum, another question, like eruption of life, eruption of biodiversity. Why did it happen? We don't know, but we know that there were like multicellular organisms, a great diversity of types and strategies. There is data for the last 600 million. We have a good paleontological data showing biodiversity of life, which grew exponentially. But there are like teeth here. The first publication that mentions that was from marine sediments, so it was connected with marine organisms, and the data was obtained thanks to concerns looking for oil, doing drilling very intensely, and paleontologists would have never afforded to do that. But then the data was made available to biologists, and what were their conclusions and findings. If you look at the number of plankton families or planktonic foraminifera, it was a famous publication. Yes, obviously biodiversity grew, but they were like collapses or troughs connected with the number of families. If there is no family, it means that all actually species were extinct. If one species survived, the family is still in place. So if half of families went extinct, it means that 3/4 of species went extinct. It was sensational. These moments were called great extinctions. So research was carried out about that. So we can also have a look at more recent data. There are not only great extinctions, but extinction is an ongoing process. The majority of species that had lived on this planet are already extinct. There are great extinctions, medium-sized, but also small extinctions. Here you can see what was the intensity of these extinction events during millions of years that I'm referring to. The last fifth extinction is the best known. Kindergarten kids know that dinosaurs went extinct, but the data show that perhaps 3/4 of all the species went extinct. What is more, even kindergarten kids know that the cause was a crash or collision with a small planetoid. There's like a dot which is almost invisible. So there was an asteroid and the speed was huge, and a huge energy amount was released, gigatons of trotyl exajoules of energy. Or you can make a following comparison. Some Homo sapiens populations have accumulated energy in atomic heads, like 15,000 of that. The energy released then was several thousand times bigger than the nuclear energy accumulated in these nuclear heads. Another great extinction, it was the third great extinction, perhaps the most dramatic. It seems that back then, 90 up to 96 of all species were extinct, so 57% of all the families, the last trilobites. What was the cause? I was clicking too fast, sorry. What was the cause? Very intense volcanic activity. So it was in the Permian Triassic era, and now we have remnants of this volcano activities like Siberian traps, so layers of volcanic lava, several kilometers thickness of the lava, and there are estimates that volcano activity led to creation of clouds that cut off the lights and made it impossible to carry out photosynthesis. And the amount of CO2 emitted can be compared with the amount of CO2 emitted now for 2,500 years. And sulfur compounds which were emitted as compared with current emittance of sulfur compounds by people and volcanoes it would take millions of years to reach that amount. So it was a huge change of the biosphere situation. When you look at the table comparing 5 great extinctions, for 3 volcano activity may have been the cause. Asteroid, planetoid may have been one of the causes, perhaps volcanic activity. As for the first extinction, we don't know. We know that 57% of genera were extinct, 85% of species were extinct. Maybe there was powerful gamma radiation, maybe there was climate cooling, maybe there was ultraviolet radiation. We don't know that. There are more questions than answers here. Yet one thing is certain: after all great extinctions, in a brief period, or brief geologically speaking period of time, biodiversity came back. Several million years were sufficient for the biosphere to have the same biodiversity like before the great disaster. And actually it was 80 million of years after Permian-Triassic extinction, but in the meantime there was another extinction. So basically that's what the situation looked like. And now, what is happening now in the mass media that I've mentioned? There are sensational headlines that perhaps we are about to begin the 6th extinction. Maybe it is beginning, maybe it is happening. What's the truth? As I've said, we don't know the answer to that. We are sure that extinction of species is happening. We have good data for that. Sensational discoveries that, like moa birds in New Zealand went extinct when human beings appeared on these islands. In Madagascar, when humans went there, huge birds, like elephant birds, went extinct. When people... I'm clicking... Somehow it is not reacting. Somehow... Well, all right. I have the right slide. When man started to invade both Americas, starting from Alaska to the south of America, giant ground sloths went extinct, big mammals, big birds. We have plenty of data about that. So these extinctions were happening also when the mankind was on Earth. In historic times, we have also dates of the last individual that died, for example, passenger pigeon or dodo bird. So there were attempts to make some calculations and come up with some numbers. Here we have registered species in extinction for various taxonomic groups, and we can compare it with a certain amount, a certain number of species existing on Earth, and it turns out, on the basis of the data that we have at hand, you can see that these are small percentages of the species which we have in place right now. But it is not the whole truth. The truth is, we don't know how many species went extinct. We don't know how many species we have now on Earth. We simply don't know that. We don't know the number of the species which exist on the Earth right now. Documenting that the species went extinct, well, in order to do that, we have to be certain that there is no single individual of the species. It must pertain to all the species living on the Earth, and we don't know that total number. So there are various attempts of estimates. We can have a look at the numbers changing within species that we know. Let's say that if for 50 years we haven't seen a single individual of a given species, we may consider it extinct. If more than 50% went extinct, it is a threatened species. So we can estimate a threat of extinction to species. There are such attempts. There is an example for various insects, for example. And you can see it here, that there are groups, for example, like beetles, which are quite threatened. Anyway, there are some estimates. We cannot be certain, but we can estimate things. How many species is there? Every year, hundreds or thousands of new species are described. And even if taxonomy is not the fields which is highly sponsored at the moment. We don't have too much funds there, and perhaps it is not highly appreciated at the moment, or as highly as it should, but thousands of species are being described, even mammals, even birds. You can see some examples in the slide, maybe some reptiles or amphibians in Indonesia, in the Himalayan mountains. 200 of species were discovered, so there were some spectacular discoveries. And if you look at a sample of soil from a tropical forest in Guyana, and you check biodiversity of nucleic acids, which define biodiversity of species. I'm not going to give you details of how it is done, but it turns out that biodiversity is really big. There are examples showing that you may find several thousand, not species, these are not species really. It is the data about nucleic classes. It is called operational taxonomic units. So OTU, there are plenty of OTUs of invertebrate, of fungi. We don't know more about these species, we just know they are there. That's it. And to sum it up, I can't say we have a certainty, but we seem to think that we know 2 million species. We don't know the definite number. How many are unknown? How many appear there? But, well, yeah, no final answer. There are various ways to estimate that. There are disputes between researchers and scientists. The number of potentially existing species between a few million to 100 million, as some people say. The more accepted data in recent years shows that perhaps in total we may have like 12.5 million species, but we know like 12% out of the total number. We don't know too much about fungi. We know quite a lot about plants, so we know a lot about 12% of the total number. All right, but there are some estimates, like rough estimates, how many species are under threat. So what's the situation? IUCN writes about that because every year they publish the data about threatened species from various taxonomic groups. And it is also a subject to criticism because, yes, well, we know all the birds, we control all the birds, we control their numbers within that species in different countries of the world, but we control just a small fraction of mollusks, even a smaller percentage of insects. And we can guess that there are like 1 million species of insects. So what percentage is under threat? Well, it is difficult to say. There are plenty of publications, as I have said. One of the most recent publications, a very decent publication, I have to say, with estimated likelihood of various numbers. So it says that now the threats for species, like 25% up to 40% of species under threat, depending on a taxonomic group. So 1/3 of species in total may be considered as threatened. If we talk about the species which went extinct during great extinctions, it was like 75% which died off or more. What are the causes? Yes, extinction is happening. Is it great? We can't say. What are the causes? Destruction of the physical habitat, extreme exploitation, invasive species. These are all causes which are man-made. All great extinctions were actually brought about apart from the first two. But the third, the fourth, and the fifth were caused by external causes. Now we can see that inhabitants of the Earth threaten biodiversity. One species living on the Earth, one species of mammals, Homo sapiens. Its biomass is 1/3 of biomass of all the mammals on the planet, and 2/3 is several species of mammals that Homo sapiens is actually keeping at home or on farms. And other species like whales and others are just a few percent. It's been mentioned that the biosphere has been changed to such an extent that actually the most natural biomes that survived are the Sahara deserts. But there is one more thing that is also very important. The Homo sapiens, this particular species of mammals, increased its energy budget, and it's happened very radically. So it was happening 2.5 million years ago, and actually it was caused by cyanobacteria. But if a demand for energy is then 10 megajoules, the average globally is 2.5 bigger of energy derives. In some places on the globe, it is 7 times this number. In Europe, it is 3 times more. So it means that there are also countries where this energy usage is slightly above physiological demand, but there is a lot of pressure there to go up with this energy consumption. Energy used by man is what was accumulated by photoautotrophs, oxygenic photoautotrophs for hundreds of millions of years. I'm not going to discuss it at length, so we have a trouble to make do with the resources that we have. So, all right, extinction is a place. We have problems with resources. So would you say that Homo sapiens is endangered as well? If you look at the curve of growth of numbers of Homo sapiens individuals, there is no threat here. This curve is going up very dynamically. It is very steep, almost 8 million individuals of this particular species on the planet. For the last 300 years, we can see that the growth rate for population has been changing. The maximum peak was in 1968, but the forecast that there will be a mild growth, that it will be growing mildly, and then small decline will happen. Actually, it is wishful thinking. It is not documented or proven in any way. We don't know what will happen, how it will happen. Someone who studied population ecology in the lab or in field knows very well that if a given species is beginning to multiply and occupy a given surface, there is exponential growth of number, and then it is not like a subtle slope to a stable level. No, there is oscillation or fluctuation or going back to zero. I don't know what may happen to man in this context. I don't think that man is a species which may go extinct, because even if due to lack of resources, some subpopulations of the species which have nuclear energy will start using nuclear energy. Even these amounts which are in place will not be launched. Perhaps extinction will go up, maybe the number of individuals will go down for this species, but I don't think that the species will go extinct. Is it immortal? No, it is not immortal. Life on Earth actually has undergone its whole course, almost whole course, I would say. So if we have a look, 3.8 billion years ago was here, we are here, solar radiation is getting more and more intense. So geologically speaking, very soon there will be absorption of the whole CO2. This episode is growing. CO2 is just an episode. CO2 will be absorbed, and then photosynthesis will stop, and the temperature will be growing, and in 1.5 billion years there will be 50 degrees average temperature, so the whole water will evaporate, it will be broken down, hydrogen will be released. I'm not going to discuss it, that's not my field of expertise, I don't know too many things there, but more or less in 1.5 billion years the Earth will become sterile. Well, okay. It's not our problem, actually. I don't know how to... Yeah, so basically that's all from me. Thank you very much for your attention. I am sorry, but if speakers are not using the mics, they will not be interpreted because we can't hear them.
Dziękuję bardzo, dziękuję.
Thank you. Elżbieta Kuteń, the Institute of Botanics. I have a question about the following. What goes extinct, because I know that species go extinct nowadays. I'm talking about plants. But new of them appear in plants. We have the following situation. There is hybridization, they are hybrids, they are polyploids, new species. We know that for a fact. Do you think that it may make up for other phenomena that many species will went extinct, but their genes will remain in hybrids and in new species which will appear? We work on species which are under threat of extinction, and I observe this situation. This species has fewer individuals, there are smaller populations, but it is replaced by hybrids and species which arise. Do you think it can make up for extinction? I don't know about animals because isolation barriers are different than for plants. I was trying to show that if you look on the time scale, geological time scale, we have the great extinction or medium great extinction. In a few million years, we'll have the same number of species that we had before the beginning of human civilization, because species crop up. That's true. It's difficult to observe. Maybe it's easier to observe for plants than for animals. But obviously, for certain, new species appear. But it is very easy. Sorry, it is not very easy. It is very difficult to calculate that, to give any numbers. Yes, and one more thing. You've mentioned that new species are being described. Does it mean that they are described, or maybe they were not recognized in the past? They are described. Yes. My point is, did they exist? Well, both can be true. In some cases, it may happen that a worm, earthworm that we knew in Poland, it turns out to be two species, morphological differences, but also new species, totally new species are being described. So both answers are true. Thank you very much indeed. Now it's time for a coffee break, and please be back 10 minutes before 12, 10 to 12. Thank you.
which is taking place much faster than any natural global warming events in the geological past. So the research that I would like to present today is going to partially answer the question, is our planet becoming too hot already? And so the background to this research is this. Under climate models, under predicted scenarios, a climate change, a global climate model that was published 5 years ago in Nature, Climate Change, predicted that the Gulf region especially will become hot. It will be one of the hot spots on this planet. And wet bulb temperatures are expected to exceed 35 degrees in the year 2050. Now, wet bulb temperature of 35 degrees means extinction for animals. And last summer, on the hottest day of the year, I measured wet bulb temperatures in excess of 33 degrees. The hottest area, the area most likely to suffer most from global warming, will be the area of the Gulf between Qatar and Saudi Arabia. In other words, on the island of Bahrain, which already is the world's second warmest country on the planet, the warmest country being the Maldives. Sea surface temperatures in the past 10 years, this is according to observed data, have already risen by about 0.5 degree in the last decade. And we, in the past few years, have been out doing field work, measuring temperatures, and I can already show you, I'll present today, that in certain parts of the Arabian Gulf, the surface temperatures in lagoons and mudflats already approach 60 degrees during the summer. So, Bahrain, the second warmest country on the planet. Our first locality that I will show you is a small lagoon on the east coast of Bahrain, where we put in monitoring stations, temperature monitors, and we were measuring substrate temperatures. In other words, surface temperatures on the surface of the intertidal zone. And the first locality that I will show you is a mudflat, and my colleague here is taking samples along a transect in the mudflat. And in the warmest time of the year, in August, I can tell you that from sample station 1 to 3, there are no living organisms. No nematodes, no foraminifera, no ostracods, nothing. And that's because the surface temperatures reach 52, 53 degrees in August across this mudflat. The gastropods, the snails, have an interesting response. So it's very noticeable that in the summer, where the surface temperature exceeds 40 degrees, there are no living snails. Only dead specimens were found. But where the temperature of the substrate is less than 40 degrees, the snails are found. They have an interesting response to the increased temperature. They form small pyramids. They very quickly assemble into groups, forming pyramids when the tide goes out. So at low tide, you see them here. And measuring the temperatures, the lucky snail at the top experiences temperatures that are about 4 degrees cooler than the substrate itself. So that's one response of an animal in the intertidal zone to increased thermal stress. So our first observations were such. As the tide goes out, as it recedes, the exposed snails, they form clusters and they become comatose at 40 degrees, well, around 37 degrees. And the lucky snail at the top is the survivor of these periwinkle pyramids. So anyway, the next site that I will discuss is a site in Saudi Arabia. not far from Dahran, which is where our university is located. The bay here is called Half Moon Bay. And we have a site, a monitoring site in a small village called Zabna, where we have a natural coastline, so Half Moon Bay. Our colleague here is standing on a barrier, sand barrier. We have tidal channels that are active at high tide, bringing water to a high tide lagoon. So in this lagoon, I've set up some temperature monitoring stations, and we have been doing temperature observations and, well, observations of the fauna at monthly intervals over the past 2 years. And in such a high tide lagoon, we have, in winter, all the fauna that you would expect: gastropods, ostracods, juvenile fish are present. You see the gastropods leave trails in the sand under the water. We measure the temperatures of the substrate throughout the course of a year. And we have a monitor that measures temperatures at a 15-minute interval. So the annual cycle of temperature in the lagoon ranges from around 13 degrees in winter to over 40 degrees in the summer. During times when we have flooding events, the temperature is somewhat cooler, but when the mudflat is exposed to the sun, it warms up. And a better record is the hourly temperature. Temperature is measured on an hourly basis. In our lagoon here, as you see, in the summer period, from June to August, we have temperatures exceeding 55 degrees. I measured temperatures of 60 degrees in our lagoon last summer. In fact, on October 13th, just last week, I was out measuring temperatures, and the temperature is still 55 degrees. So one might ask, what effect does this have on the organisms that live, the intertidal organisms that live in such places? Well, here is the annual cycle of temperatures. In winter, we see from the beach, which is here, across the sand, into the lagoon, temperatures are rising from the shoreline to the lagoon. Already in April, we have temperatures in the lagoon exceeding 50 degrees. That's on the substrate. And by August, we're measuring temperatures approaching 60 degrees in the lagoon. This situation, this summer situation, lasts now from April until October. So the lagoon really is habitable by animals only during winter. Okay? The monitoring station that I'm talking about is just here at the edge of the lagoon. And we're seeing temperatures that are obviously lethal to organisms. We observed a fish kill on the 15th of May. We visited the lagoon at the beginning of May. There were plenty of juvenile fish. On the 15th, all were dead. The next part of our experiment was to determine the thermal limits of these benthic organisms that we collected from the lagoon. First the gastropods, then the ostracods. So we are now conducting culture experiments to determine their thermal limits. Surprisingly, there are no data reported for the Arabian Gulf. All such experiments were done in Singapore. And we have 3 trials. On one Petri dish, the organisms are covered in water. On the other, they are partially covered. And on the other, in the third Petri dish, they are just placed on the wet mud collected from the lagoon. And we expose them to several regimes of temperatures first 40 degrees, in the lab 45 degrees, 50 degrees, 60 degrees. And at the lower temperatures, for example, at 45 degrees air temperature, the mud in the Petri dish heats to a temperature of about 40 degrees. At 50 degrees, the temperature of the mud is about 42 degrees. And at 60 degrees, we reach 50 degrees substrate temperature in the Petri dish. Now, what about the survivability? First, the gastropods. So, on the exposed Petri dishes, the snails stop moving and become comatose after about half an hour. Although the ones covered in water will survive. And that's at 45 degrees. At 50 degrees, we have fewer survivors. All right, the exposed snails all become comatose after half an hour, and some of the other groups will stop moving. But this is important. At 60 degrees air, which corresponds to about 47 degrees substrate temperature, all snails become comatose and die at about 47 degrees. Moving on. Here, we normally report, in terms of such experiments, the thermal limit 50, which is the temperature at which 50% of the specimens will die. So for the snails, we determined the TH50 at about 47 degrees. So that's about the thermal limit of marine snails. So when you plot a 47-degree temperature on our annual record of temperatures measured in the lagoon, we see that the substrate temperature already exceeds the thermal limit of the gastropods around the second week of April. And it extends, this is data for last year, it extends until the second week of October. Well, this year, we're going to have to extend this graph a little bit more because the temperature is still warm. And anecdotal evidence, I've interviewed some of the oldest colleagues that I have at the university, they always tell me that in the past, when I first started at KFU PM, summer conditions ended in the middle of October. Now it lasts until the second week of November, right? So we already have a situation where in large parts of the Arabian Gulf, in the intertidal zone and in the supertidal lagoons, we have death traps for the marine benthic organisms. Any fish, any gastropods, ostracods that are unluckily washed into the lagoon during the summer probably die within half an hour at such temperatures. So, yes, we have the ostracods. And I should be able to show a little video. We already have conducted our experiments with ostracods, which are małżuraczki po polsku. Małżuraczki. And I suspected that the małżuraczki would be survivors because they tend to be present in the summer where other organisms are no longer found in the samples. And yes, we did the same experiments, the thermal limit experiments, and we found that about half of the specimens die at around 48 degrees. 48.5 degrees. And at 51 degrees, all the specimens are dead. So yes, the małżuraczki are the survivors. All right, they survive slightly increased temperatures, but still, the lagoons are death traps for all these marine benthics. So, our conclusion. What will the next mass extinction event look like? Where will it begin? What is one of the mechanisms that's going to cause a mass extinction of marine organisms? Well, this is one of them. The Arabian Gulf is getting warmer, it's measurable. The summer conditions are becoming longer each decade. And the temperatures in lagoons already exceed 42 degrees water temperature and 60 degrees substrate temperature. And such temperature is well in excess of the thermal limit of these marine organisms. So we have summer kill zones on mudflats in high tide lagoons where the substrate temperature is enough to basically cook the marine organisms. Consequently, the habitable period for these organisms is now restricted to the winter conditions beginning around the middle of November. So, the conclusions of that paper published in Nature Climate Change, that the Arabian Gulf may become uninhabitable for marine benthos sometime by the year 2050, well, now our data show that such conditions already exist. So we need to take climate change seriously and see what effect they will have on the biodiversity. And I thank you.
Thank you very much for interesting talk. And questions, please. O, pytania, proszę bardzo.
So if my memory is correct, 55 degrees is when proteins begin to coagulate, is that correct? So you're biologically showing what is already known. The question is whether the fact that you're using small mammals has an implication on the wider predictions that you're making. Because, I mean, we ourselves, you wander around in 60 degrees and you're not coagulated yet.
Well, yeah, that's very true. And we have the additional advantage that we can always go into our air-conditioned cars when we get too warm on the mudflat. But the fact that these animals are small means that they become comatose more quickly. So, and after they become comatose, they often die within a couple of hours. So these animals, the foraminifera, the ostracods, the gastropods, form the basis of the food chain for the other marine organisms, for the fish, and therefore for man. And if we are having problems with the base of the food chain, we're going to have problems further along the line. So that is why we're determining, the duration of the kill zones, their aerial extent, and the possible implications.
Yes, we have time. Przepraszam. Mamy czas jeszcze jedno.
We have time for one more question. Unfortunately, the interpreter cannot hear the question.
Nie mam danych na ten temat, niestety. Tak, ja obawiam się, że
I'm afraid that the supertidal lagoons, they are the pods, the breeding pods for juvenile fish. And their period for staying in such lagoons is getting shorter.
Dziękuję. A teraz dwa ostatnie.
Thank you. And two more lectures that will focus on men, actually. And Professor Alicja Juskowicz will have a lecture. We will not die so quickly, how challenges shape our immunity. Professor Juskowicz is interested in aging of cells, stem cells, and hematopoietic stem cells processes. She is the author of many publications, more than 10,000 citations. And now the floor is yours. Will we survive?
Ja staram się być optymistą, jak widać musiałam zmienić okulary, bo w tamtych nie widzę nic, a w tych widzę tylko troszeczkę, ale jakoś spróbujemy sobie dać.
Okay, I've tried to change my glasses. I hope I have. Oh, right, yes. So I will be closer to the mic. Is it better? All right. I just wanted to say that I'm trying to be optimistic. I had to change my glasses because in the other glasses I can't see a single thing. These ones are a bit better. So, first of all, thank you very much for giving me this opportunity to meet you. It is a great honor for me, really it is. And I am aware that we'll not die so quickly. This title shows that when God was distributing common sense, I was standing in the queue for optimism, but I do believe that there are grounds for optimism, and I will try to show you my line of thinking. There is no doubt that challenges, problems, and difficulties, well, we have experienced that throughout our history. And if we look at historical sources or literature, we can see that all the time there was information about infections, pandemics, typhoid fever, smallpox, plague, or other great troubles, really. So I would say that the problem we are facing right now with the development of medicine that we witness at the moment is still a smaller problem than what our predecessors experienced. And our predecessors were not hopeless and helpless either. They had an immune system, and we have an immune system too. So it defends us. It is developed on the basis of hematopoietic stem cells in human beings. It is in bone marrow. The effector cells infiltrate tissue. The level of activity of our immune system is really impressive. Within 1 second, we have 1 million granulocytes appearing, and they watch and they do not allow infections to develop. So how we can treat people, how we can prevent diseases, it results for a lot of knowledge of our trained immunity. It is mediated by lymphocytes. But we also have our innate immunity, and these granulocytes, monocytes, macrophages are also active all the time and defend us all the time. Here, an image of 2 busy macrophages which are trying to deal with Streptococcus. So vigilant all the time. Macrophages have difficult lives, bacteria are plenty, macrophages are busy all the time, but bacteria have difficult lives too. Bacteria fall ill as well. They have viral diseases, so a different image. Zooming in, and you can see Streptococcus being attacked by phages, and they are not helpless either. They have their defense mechanisms, which are very complex but very effective. And we as scientists investigate these mechanisms. It is fascinating. But secondly, we can learn a lot and use this knowledge in different places, unexpectedly to develop therapies. I know these are textbook cliches, but I wanted to show you two classical examples. Bacteria have a system of metallases and endonucleases. So endonucleases recognize very short DNA sequences which randomly appear. They are very short, so they will appear in every DNA strand, also phages DNA, if it has the right length. If endonucleases recognizes the sequence, it cuts the DNA. But there are also metallases which recognize the same sequences, and they methylate DNA. So if it is methylated, nucleases cannot cut them. So how does it work? If we have phages attacking bacteria, it gives its DNA to bacteria, and the nucleases may cut it. DNA of bacteria is safe because it is methylated, and it is a system which was examined since the end of the 1950s, especially in the 1960s and 70s, and we scientists, in a broad sense, scientists, not myself personally, we scientists understood how the system can be used as a biotechnological tool, as a fantastic tool which allows us to design in which place cutting DNA should occur. Then you may take a different enzyme and you may glue these fragments together. And such techniques led to development of gene cloning, recombination of genes, and to the publication like this one. It was in 1979 about methods of production of human insulin in bacteria, and at the beginning of the 1980s. Humulin, which is human insulin, was introduced into the market. There is a possibility of production basically of such insulin, and it happened thanks to our bigger knowledge of defensive mechanisms in bacteria. Bacteria can also remember what has happened in the past and what kind of threats may appear, so they learn. How does it happen? Genome fragments attacking phages are built in the CRISPR locus, and then the transcript from this loci is used by ribonucleases, Cas, to create small, short RNA strands. If they meet complementary phages material, they induce destruction of this genetic strand. These mechanisms now intensely examined and investigated. It is a very popular and important topic. It's been happening like that for the last several years. At the moment, these studies revolutionized our reality in labs. We have ability to edit the genome. We can build in mutation or delete a mutation. We can correct a mutation. It is a reality or a revolution in the lab. But we need just a little bit of imagination to believe that it will be the future, clinical future in some genetic diseases. So it will be possible to take stem cells, mostly stem cells, correct mutations, and repaired stem cells may be given back to the patient, and the root cause will be eradicated. The first clinical trials are there. They were performed in patients with beta thalassemia, and they showed that such therapy allowed to drastically diminish the number of necessary blood transfusions. So it may work. But the biggest benefits are from direct studies of our immune systems, especially of this part, which is the trained immunity reaction, because it gives us a specific memory. It is the foundation for vaccinations, and vaccination is like the biggest discovery, the biggest achievement, and thanks to that we can think differently about the reality and about diseases, so we don't have to die of tuberculosis. So when we see a pathogen in the first period, it is innate immunity cells which start fighting with the pathogen, but then lymphocytes are activated, and then trained immunity is the most important. After the end of infection, we have long-living memory cells, thanks to which, in response to meeting the same antigen, we'll have a reaction of our immune system which will be faster and more efficient. And that's the foundation for inventing vaccinations. Vaccination as a humanity appeared before we even fully understood our immune system. It was based on observations of results of certain activities. First vaccination seemed to be introduced in China like 1,000 years ago. It was against smallpox. And actually the material was taken from bladders of patients who fell ill with smallpox, and it was given to inoculated people. But there were certain procedures, like you have to keep it 1 month next to your body or above the water vapor with some herbs. I guess these procedures allowed to attenuate the virus, hence the procedure was not dangerous. The first description was created in 1549. You can see a fragment of the manuscript here, and the details of preparing this material for vaccination were described. In the 17th century, it seemed to be a popular procedure in China. It was given to Chinese soldiers. A very similar procedure of smallpox vaccination, so taking materials from the patients and giving to healthy people. A similar procedure was introduced in the Ottoman Empire by Dr. Zwe, and these procedures were known in what is now Turkey and Northern Africa. And it inspired Great Britain and Europe to introduce vaccinations. The first vaccinations in Great Britain with material taken from patients ill with smallpox to prevent smallpox in others was the first half of the 18th century. But an actual breakthrough took place thanks to this man, Edward Jenner, was an ornithologist, so he was an expert on birds. He was accepted to the Royal Society because he was writing papers on cuckoos, because he explained why cuckoos behave as they do. So it is a mother cuckoo. It does not like remove other eggs from the nest of another species, but it is a small cuckoo who does it after they are hatched. So they are the only egg and the only individual in the nest. So he was a respected scientist, and he did something very important. In 1796, he did something pioneering, namely it was inoculation of an 8-year boy against smallpox, but it was based from cowpox material. It was efficient. Several weeks later, the boy received material from the patient ill with smallpox, and the boy did not fall ill. So cowpox material protected him. So there were like 20 similar cases. Dr. Jenner described them, and it was the beginning of the contemporary vaccinology. So to give you more information about that, hence I'm optimistic. You can see that these simple activities were very efficient. You can see smallpox death rate before inoculation at the beginning of this process in Great Britain and later on. So actually smallpox was eradicated. And then have a look at polio numbers. Introduction of vaccination against polio at the time of the 1950s epidemics. The situation was like that after vaccinations were introduced. In Poland, we had a very similar situation in 1959 due to personal involvement of Professor Hilary Koprowski. polio vaccination was introduced. He was the author of the first polio vaccination. We have to bear in mind that fact. And there was a big pool of polio vaccinations in Poland, and polio was eradicated in Poland. So we have grounds to be optimistic. And we test mechanisms of immunity. We understand them better and better. We understand how this specific immunity works, but it seems it is not the end of the story. We know that, but there are so many things we do not know. Many observations point to the fact that our innate immune cells, macrophages, can learn, they can remember somehow. If we look at the intensity to the response to the first stimulation, it is usually milder than intensity of response to the second stimulation. They learn, but learning is not antigenic specific. It is not antigen specific. It is not like lymphocytes. Generally, it is a response to stimulation. What's the biological mechanism which is at the foundation of that? It's studied intensely. Probably visa epigenetic modifications, DNA modifications, non-coding RNA perhaps, or most probably it may be regulated or facilitated by the right focus of metabolism, because enzymes depend on cofactors like NAD or alpha-ketoglutarate. But what is important, we can see results of these activities. It is not just a vision, it is a real experiment. Here, what happened? A healthy volunteer was given BCG vaccination. It is against tuberculosis, very old, introduced in 1921 from attenuated bacteria infectious for cows. It is vaccination that you give in the first days of life of a newborn. It was given to 3 billion people, so there was either BCG vaccination or placebo given to volunteers, and monocytes were checked. What about the profile of activity of monocytes? What was observed was epigenetic changes. Here it is acetylation of histons compared with placebo patients. Significantly, these epigenetic changes were correlated with the level of response of mononuclear cells to stimulation with various stimuli. If antigens were given, typical of BCG vaccination, to mononuclear cells, if there was a previous vaccination, these cells produced more interleukin 1 and 6, but also produced more when LPS was given or fungal antigens. So it was not gene-specific. Interestingly, if these patients with macrophages were tested, after 1 month, a different vaccination against yellow fever was given. It is old type vaccination, attenuated virus, which might be replied to a certain degree. It turns out that if they had vaccination, BCG viremia after virus was lower. So the virus was doing worse. Patients were responding faster. BCG vaccination has nothing to do with the virus. It had nothing to do with the level of antibodies. But definitely it had something to do with epigenetic modifications observed in monocytes in patients. Moreover, we could see that if progenitor cells from bone marrow were taken and transcriptor was made, it showed that there was increase in differentiation, myeloid differentiation towards granulocyte, more than in the case of placebo volunteers. So there were observations like that, but they can be confirmed by animal controlled experiments. One example, there was an experiment in mice with compromised immunity system. They were given progenitor hematopoietic cells from donors that had no bad experiences or which had been given LPS. It was like copying a bacterial infection, and a recipient was given bacteria, and basically it was pus bacteria. So if there was no transplant, there was no transplant of hemopoietic cells, it was defensive, and the defense was much stronger if cells were transplanted from the mouse that had been given LPS, not physiological liquid. More interestingly, if the procedure was done like that, at first there was progenitor hemopoietic cells were transplanted, then they waited for 3 months, and these cells were transplanted to another recipient, and then in another recipient, pus bacteria were given to this recipient. It turned out that a certain protective effect was there. It was not very powerful, but it was in place, and cells operated better if they were taken from a donor which had had bad experiences and was in touch with LPS. So the changes which are decisive for monocytes behaving as it does in a more efficient way, they had been there in a previous period in cells from which monocyte originated. So hence the idea, if giving BCG is so efficient and so effective, perhaps we can think about BCG as protection against other diseases, like viral diseases. These studies were carried out where specific vaccination against SARS-CoV-2 was not available. So in the transitory period was the idea, perhaps we should apply the old vaccination to have protection, non-specific protection against various diseases, including COVID. These ideas were supported by epidemiological analyses. Here you can see comparison of maps. Fatality rate caused by COVID, and vaccination programs like historical BCG vaccination programs. And you may notice that the countries where BCG was not present have a higher death rate from COVID. So we have to be very cautious about that. It is like correlation type of thinking. There are dozens of various factors. Perhaps they are correlated with each other. Perhaps they are also correlated with BCG policy. But you have to be very cautious. Yet there were maps like that. If there were various tests of filtering data, you can see it was published 2 years ago, and there was like cleaning the data so that co-correlations are removed. Still, there was a certain tendency observed here. The most intriguing observations were made in Germany, because Eastern Germany had obligatory BCG vaccination. Western Germany did not. And the death rates and morbidity rate for COVID was different for both parts of Germany. It is better in the East. Well, that's the same state now, with the same reporting system, the same testing system, so it is quite intriguing, but still it is just a correlation. So we need to see clinical trials. And clinical trials were conducted. It was published a few months ago in Lancet. 1,000 people were divided into 2 groups. There were people connected with healthcare, so exposed directly with the possibility of COVID infection. Half of them received placebo, the other half received BCG, and they were observed for more than a year. You can see what happened. Nothing. No results. No results. Nothing. So I'm optimistic. Here it is difficult to be optimistic, perhaps, because if something doesn't work within several weeks or months, you can't imagine it makes any impact on reality into multi-annual perspective. It is not logical unless we look at other kind of cells, hematopoietic stem cells. Individually, they can recreate the whole blood-producing system. They are usually dormant. That's what they do. Most of the time, they do not think about several days or several weeks. They are dormant. Sometimes they wake up. They may self-regenerate, self-renewed, or they may give rise to clones differentiated into other cells. But basically, they are dormant. And the question is, where in our immune system, which is hierarchical like that, at the top there are hematopoietic stem cells, where do we locate memory? Which cells remember? We know that lymphocytes remember. We know that. It seems that monocytes or myeloid cells can use memory to some extent, the trained memory. Let me put it like that. But the concept is, or the possibility is, that maybe stem cells also remember. The ones at the top, long-living stem cells, may also remember. It was a concept which originated or was by Krzysztof Schade, Dr. Krzysztof Schade. He's here in the room. I guess he will have an opportunity to check whether the concept is true, and if it is, what molecular mechanisms are there. So in a nutshell, how it may function, have a look. If we are young, we have our hematopoietic stem cells, which are naive, so to say. They haven't come across any strong stimulus. They are universal. They can do everything. They can differentiate into all types of cells in the most effective way. They have open chromatin available to various transcription factors. So this population is not identical. You have a certain information noise. You have a certain dynamic. Many genes are expressed, but at a very low level. These cells are not identical in this pool. Then you can imagine that a strong stimulus worked. Some of these cells will be prepared to respond to this stimulus, and these cells will be clonally expanded. So there will be clonal expansion. If the epigenetic factor, which made it possible to have faster response, will be preserved, these cells will function like memory cells. And if for the second time the body will come across a similar challenge, not the same antigen, similar challenge, it will be prepared. It will have a pool, the cells that will provide a better, more efficient response. So when we are younger, we have cells which can do everything with the same efficiency. Then we grow up and we are convinced that some challenges are more likely than others. That is why our cells are directed in some ways towards these challenges when we are adults and mature. Many of our cells operate like that. And when we did analyses of diversity of gene expression in hematopoietic stem cells derived from mice, young mice and old animals, we could show that diversity is bigger in young individuals than the old. So it is a fact. It is not just a hypothesis. It is a fact. What's the difference between this and the classical approach to the immunity system? In the classical approach, it is like that. When we have cells in young individuals, they are universal. It is a transitory period, and then we are aging. Throughout the aging process, our cells are more prone to produce other types of cells than others. So we know if we have this focus, linear focus, connected with aging, it means that we have losing function. When we get older, we lose function or functions, but that's a matter of perspective. Maybe it is not aging and losing functions. Maybe it is maturing and adaptation and gaining more experience. In time, we know what challenges are more likely and we have to be better prepared for them. Let me emphasize here, it is not a matter of imagination and a vision, no. It is based on experimental data. So in a nutshell, the studies headed by Dr. Krzysztof Schade showed that in hematopoietic stem cells in mice, you may identify a surface marker, NEO1 protein, which shows the cells which are myeloid-directed cells. It is very important because you can isolate these cells and check their function. Here, there are cells from old mouse with phenotype which is very specific for hematopoietic stem cells. And you can see that some of them has NEO1, some of them do not, so they are not homogenic. NEO1 plus, one of the population of hematopoietic stem cells are not that dormant. The other group is more dormant. They are deeply in sleep. And the most important thing, as time passes by, as an animal gets more mature, older, the pool of this myeloid-directed or myeloid-focused cells is growing. It becomes dominant. They are myeloid-focused. You can see that when you see the profile of gene expression and when you see the function. These cells are more efficient in reproducing effector myeloid cells. What is even more important, if we give a factor inducing myelogenesis, these cells are able to respond. It fits the model that I have just mentioned. And the last thing to convince you that this model may be efficient not only when we talk about a response to a pathogen. You may imagine that we convince a blood-generating system that we are threatened by the loss of blood. We did that to a mouse. We induced ischemic stress in a mouse. We took blood regularly for some time, and we checked what will be the result. As for leukocytes, nothing was happening, but clearly erythrocytes went down, hemoglobin went down, so it was anemia that we caused. On the basis of the red cells data, we could see that anemia is accompanied by erythropoiesis. We wanted to see which cells are responsible for that, and the result was clear. What proliferated in response to the stress? Progenitors. So progenitors responded, so the ones that should proliferate. Hematopoietic stem cells, dormant nights, they did nothing. They were still asleep. Nothing, no proliferation. So we checked transcriptome, and actually nothing was happening. Perhaps several genes were changed. So actually we stopped there for some time, and then we had a closer look at the data. It turns out that among several genes that were changing, the most changed was incretin number 1, which is typical for differentiation for erythroidal, and still it is about hematopoietic stem cells, which did not proliferate. And here you can see something which was done yesterday. It is a group of genes connected with erythroidal. So there was no proliferation, but something was beginning to happen. So these cells realized that erythroidal differentiation will be much needed. So let me sum it up. If this model is true, it seems it would allow us to tell a full story, including 3 separate stories about epigenetic changes in stem cells, about the fact that cells in time are subject to expansion. We have more hematopoietic stem cells than our students, and about the fact that in time there is a linear focus. If this model is correct, it may have significant clinical consequences, especially if we think about transplanting blood-generating cells. What about consequences, whether this model is true, mechanisms? I guess the author of this concept will tell you more about that on another occasion, maybe not during the Jubilee conference, but at some time in the future. The majority of the data is from trade press, but some of the data was generated thanks to studies of Dr. Krzysztof Schade, Dr. Agata Schade, with the support of the whole team. There is a long list of names with a lot of support of Professor Irving Weissman. Thank you very much for your attention.
Na pewno dyskusja byłaby bardzo ciekawa.
I guess we would have an interesting and lively discussion, but there is no time for that. Now it's time for the next presentation. And the next presentation will be by Professor Richard Frackowiak from École Polytechnique Fédérale de Lausanne, Emeritus Professor, University College London. So he will be our next speaker. Professor is a pioneer of studies using neuroimaging of brain.
So the professor's works are the most frequently cited at globally, the H-index 209. That's incredible. That's beyond belief. So, Professor, the floor is yours. Thank you very much for invitation. Well, excuse me, but I'll be speaking in English because my Polish stopped in 1948 when my parents left Poland, and the vocabulary over the past 70 years evolved.
I will make my talk a lot shorter so that we can all go to lunch at time, and I hope you'll be very happy. I'm going to project forwards because I heard that this was the origin of the 150th anniversary, and I thought that was a very nice idea. And so I'm going to talk about experimentation on the human brain in vivo, carried out with non-invasive methods. And these are MRI scans. Those of you who are in the social and historical sciences, you don't really need to know what is happening here, but you can see the brain from below upwards on the left here. You can see the brain from the side. There's the nose, the eye, and then you can see the brain from the front. And these are 1 millimeter cubed images. They can be collected in about 4 or 5 minutes, and they represent the state of the art in radiology. Now, I wish to make the great distinction between radiology and clinical neuroscience, which is what I'm going to talk about. The first thing about science is that it must become quantitative. And the MRI images to date have not been. So there is a great advance recently done particularly in Lausanne, where maps of the brain, this is exactly the same level of the brain, reflect different aspects of physiology, water content, myelin content, and so on, where measurements can be made at the level of resolution in absolute units, which means that we can compare, we can contrast, we can average, and we can get variability. So this is now in the laboratories and will become the future in radiology. But we must remember that in neuroscience, we can't only look at the mesoscopic level to understand what is happening, but we also have to remember that in addition, we have various pathophysiological methods. For example, now I've done something wrong here. Go forwards, my boy, that's it. And then we have at the anatophysiological level, we have at the electron microscopic level, we have at the even better cryomicroscopic levels and histological levels, different aspects and organizations at spatial level, quite apart from the temporal level. In fact, over the last 40 years since neuroscience has become a discipline, we have generated vast amounts of data at vast levels of spatial resolution, from cognitive studies, through tissue studies, through cellular, and through molecular, and finally also biological resolutions. So the first question we have to ask ourselves in looking to the future is, do we have enough data in the literature? There's about 150,000 to 200,000 papers per year generated in the literature in neuroscience at these various levels. So how are we going to manage this? How are we going to deal with this? And this is what I think is going to be the game changer. The first thing is that we are very much better now at data management. Just think, those of you who are old enough, how much it costs to get a disk and how much it now costs to get a little SMS card. The distributed computing, just think of Netflix and think of what you could do with vast amounts of data, moving them from hospital to hospital, moving them from all areas of the world to a center where you could do research from existing databases. Think of systems analysis, where one begins now to use artificial intelligence like DeepMind and other things, where you don't just look at correlations, which we heard explained very nicely just now, but we can look at interactions between different areas, so that we move from the Platonic trigonometry, the linear world where A causes B causes C, to the real world, the multidimensional world, where A causes B under context alpha, but A causes C under context delta. These are interactions, and they lead to patterns which change with the environment and which change with the context: disease, normality, male, female, Caucasian, black, everything. And these methods are now showing extreme power. Many of you will have read 6 months ago that a company called Dataflow has generated the three-dimensional structures of all 20,000 known biological proteins. This opens the door to creating artificial proteins for therapy. This means that electron microscopy and other forms of examining the structure of a protein, which can take 3 to 5 years per protein, can now be done much more quickly, because we have the templates accurate to about 95% for all of them already. We're also now getting advances where algorithms are improving how algorithms work. So this whole area of modern statistics, pattern recognition, and deep learning is making available for analysis in very large numbers of all the data that are already out there. And this makes us change our way of thinking in biology, indeed in science. Gone is the Victorian concept of the genius. The genius, of course, is the person in the right place at the right time who happens to be standing on the shoulders of multiple people. Here we now have the possibility not of generating hypotheses from individuals, but from generating hypotheses from the data. So we would take the data, examining them with powerful algorithms, rank them according to statistical probability of explanation of the data into models, and then doing reductive analyses of a classical type on these hypotheses, greatly increasing the way and the efficiency of carrying out science. So we move at last from Descartes, who's about 400 years ago, with a top-down method which all our grant-giving bodies give us money for and don't give us money if we don't have a hypothesis, and comes away with correlations which anyway, as we were just told, are non-causal, to a method where we use simulation, the data, to generate the hypotheses. Don't think that we are very clever. Engineers have been doing this for 30 years. Aircraft have been created in this way. Going to space has been done in this way. That the multimodal and multivariate analyses of multimodal data are carried out in highly sophisticated fashions to make machines. So the fact that we as biologists and clinical scientists are so far behind is not very good for our reputation. Now let me just give you one example of a simulation. This was a simulation that was planned in the Human Brain Project and was abandoned 3 years later for political reasons, which is terrible for Europe. But never mind, let's tell that story some other time. As you know, we have various models of the organization of various parts. I want to get that other one because this is small. Let me go back again. Click, click. That's it, I think. Yeah. The Hodgkin-Huxley equation, most of you who are in neurobiology know. It's quite a simple set of equations. It tells us how impulses go down nerve cells. There are many such equations. We also have a lot of histopathology, one of the oldest parts of clinical neuroscience, where we have masses of data about what types of cells are found in different layers of the brain and how these different types of cells connect to each other and what frequency and with what variability. We have measurements from electrophysiology which show us how pairs of cells interact in different states. Here's a pair of cells. Here are responses from different cells at different stimuli compared to no stimulus. And we now have these models to allow us to create a simulation. In other words, to use now a data-driven hypothesis to suggest how these models can be generated. And here they are. Here we have real data, and here we have simulated data, and here we have a monosynaptic excitation for real and simulated data, and here the same in a disynaptic inhibition for real and simulated data. So at every level of organization, if we can find the rules, the way that cells or molecules or whatever interact with each other, and if we have a complex object to examine like a human being, we should be able to move up from one level of organization with its rules that limits the rules for the next level of organization that limits the rules possible for the next level of organization, and so on, giving us a possibility of simulating something as complex as a living being or a living set of neurons or cells which are protecting us from infection or whatever. So that's the conceptualization of the thing. The first critic that came for this sort of model, who didn't know about the engineers and everyone else, said this is a pharaonic idea and is totally impossible. I'm glad to tell you that 10 years on, he now is a great proponent of this idea, because it was pointed out to him that if you're starting off with something as simple as a DNA code, which contains just those 4 different molecules which adapt in a very simple fashion, interact with each other, you have already limited the infinity of degrees of freedom to a very simple set of levels of degrees of freedom, which you can then build upon, creating fewer and fewer and fewer degrees of freedom and making results more and more accurate with lower and lower variability as you add in more and more and more data. Imagine if you do clinical trials. You don't have to do randomized controlled clinical trials anymore. You just give an agent and you see how it does what it does, and you continue to collect data until you reach an asymptote with a minimal variability. There's no need for comparisons. And so I'm opening up a number of ideas here. At the end, I'll show you which of these need to be validated, which of these need to be shown, and so on, but the story needs to continue. And so, here we go again. Click. Yep. The here and now in medicine of the brain is that phenomenology alone, which we've done for 150 years, where we call diseases when they're actually syndromes and not diseases because we don't know the mechanisms, is insufficiently discriminative for a good diagnosis and prognosis. We thought that the Human Genome Project would give us keys. This gene abnormality gives you this disease. We know that to be wrong, but we also know that we have found out an awful lot about genetics, which has allowed us to advance. Now, from my point of view, using the data that I use, 1 millimeter cubed, one of these 1 millimeter cubed elements in the image of the brain I showed you at the beginning is called a pixel. So the question now is, can I demonstrate with deep learning, for example, that there are specific patterns of pixel abnormalities that are much more specific diagnostically and have prognostic significance? And this is where artificial intelligence and informatics will meet medicine. And the answer to that question is yes. Now, there will be many new answers along the way, but essentially the answer is yes, and I'll give you one example. So here is an AI method called support vector machine. It doesn't matter what it's called. But on this side, you see that there's a group of people with a similar syndrome, and you can divide them into two groups, Group A and Group B, by a function, a mathematical function that is not a straight line in reality, but is highly complex. Because the amount of data we're going to use here is all the clinical data, all the imaging data, all the historical data, and as many data as we can get for this syndrome and then for the individual patient. We can now know that when we make a clinical diagnosis of Alzheimer's disease, in 20 to 30% of cases in all hospitals, including the Mayo Clinic and National Hospital for Neurology in Queen Square, we're wrong. All right? Why? Because we take the people after death, we look at their brains, and they've got a different cause for the syndrome of dementia, which for some reason we liked to call Alzheimer's disease, but Alzheimer's disease is only one cause of dementia. There are probably 100 of them. For example, Muhammad Ali, another cause of dementia, and Parkinson's, and so on. The sensitivity with which we can distinguish the syndrome of dementia from clinical normality is about 60% using current tests in life. And the specificity is better. It's over 90%. And that's why we get a correct diagnosis. In this case, this is a group which has the best diagnosis rate I could find in the literature. Now, we take the binary classification by support vector machine. We train it. We train it with all the data we have. But we have to be careful. So I asked my friends around the world to send me images of the brains of people who are completely normal and old, and the brains of completely demented people who are also old at about the same level. And the test was that I didn't want to see the scans unless all the patients were dead and all the normal people were dead, so that the pathologist could tell me whether the dementia patients were Alzheimer's disease or another cause of dementia, and whether the normal people were normal pathologically or were in a preclinical state with an abnormal brain already, but normal. So this is a very nice little Latin square design looking for the interaction between the clinical manifestations and the pathological manifestations, asking the question, can we identify those who have the disease and have the abnormality of the brain, and distinguish them from those who don't have the disease but do have the pathological changes, who are presumably preclinical. We did this for an enormous database called the ADNI database in California, which is the reference database everyone uses. They're in a very small group in this case, and their clinical diagnosis of Alzheimer's disease in 15 patients out of the 20 that they classified in life as Alzheimer's disease had the pathological changes, but 5 didn't. They had other pathology. And in the clinically normal subjects, which also there were 20, 3 of them had the pathological changes of Alzheimer's disease, and only 17 were completely normal. Now think of doing a randomized, controlled clinical trial of dementia, because the pharmacological industry want one pill for all the diseases that lead to the syndrome, and normal, 30% error variance on one side, 30% error variance in the normals, because they already have it, and away you go. So the final slides I'm going to show you, 2 of them, show you taking this one step further and showing the way forward. So here we got imaging data from about 6,000 people, of whom 5,500 were clinically healthy controls, and about 1,900 had dementia, right? And we had clinical scales and measurements, we had imaging, we had molecular biology on a proportion of these, we had proteins from the cerebrospinal fluid, which are used as biomarkers, from another proportion, from the cerebrospinal fluid and from brain, and we analyze them now with a deep learning algorithm. There are 3 types of ways you can analyze this mass of highly different data. It's multimodal and multivariate, because the ways that the different components can interact with each other are massive. And it's the way that our supercomputers, and now very rapidly even our portable computers, are able to do these sorts of calculations. One is to use the clinical diagnosis. This isn't easy, is it? There. To use the clinical diagnosis as a sort of semi-supervised way. Use the doctors to tell us what they think, how should it be, and to analyze the data. That's one way. Another way is to get our colleagues in the labs to use these biological features, proteins, genes, and so on, to give us a biologically led classification based on their data. And then there's the deep learning, which is the fact that we've taught our classifier machine on real data, real Alzheimer's, dementia without Alzheimer's, the 4 cases, and see what the deep learning suggests and shows. And this is the answer. We took people who had the clinical classification, normal controls, people with dementia. We integrated the imaging data. We found 4 types of people that I've already described to you. And we find that those who have a classification pathologically and who develop dementia, those who have a dementia which doesn't have the pathological changes have a rate of declining to death which is much less than those who have a classification of dementia, who develop dementia, or who are demented, and who come to death. These differences are massive. So the ability to do this pre-death is not only that preclinical diagnosis becomes possible, which opens the road to therapeutics before the disease occurs, but also it is prognostic in the sense that it says if you have dementia and the pathological changes, you will die more quickly. And if you are normal and have the pathological changes, you will die more quickly than those who do not have the pathological changes, whether they are demented or not demented. So these are important things, And I think this is the way things are going to go. And I think that I have probably said enough because I know we're short of time. I'll leave these things for you. The to be proven, you might like to read. So because I've done a lot of suggesting here. To be proven, and to be validated. If you're interested, please read on. Thank you very much.
Tak, ponieważ
Excellent. Because
przekroczyliśmy czas,
because we ran over our slot and we will have our lunch break, I suggest that we just have to take one question, not to deprive you of the opportunity to ask questions. I would like to thank once again all the speakers. Your presentations were very highly stimulating and very interesting. Thank you.
proszę Państwa, przerwa jest do godziny 14.
Ladies and gentlemen, I'll see you back at 2. And let me remind you about this donation collection.
Można składać datki dla Towarzystwa Naukowego w Żytomierzu. Zachęcam Państwa.
Dzień dobry Państwu, nazywam się Marek Sanak, poprowadzę sesję medyczną 19 października, to jest środa. Sesja będzie zatytułowana 150 lat współczesnej medycyny. Właśnie tutaj, w dużej auli PAU przy ulicy Sławkowskiej. Mamy wspaniałych wykładowców, których poprosiliśmy o przedstawienie ich tematów w języku przyswajalnym dla niespecjalistów z dziedziny medycyny. Pierwszym będzie profesor Jerzy Kupiec-Węgliński z Uniwersytetu Kalifornijskiego w Los Angeles, który nam opowie o przyszłości transplantologii. Głośny przypadek przeszczepu świńskiego serca człowiekowi, myślę, że na pewno zostanie poruszony w jego wystąpieniu. Drugim będzie pan profesor Marek Radomski z Kanady, z Uniwersytetu Saskatchewan, który komentował całą pandemię w mediach kanadyjskich i opowie nam o triumfie oraz o wątpliwościach związanych z postępem nauk w dziedzinie chorób zakaźnych. Z kolei członek naszego wydziału, profesor Józef Dulak, opowie o możliwościach terapeutycznych przy użyciu komórek macierzystych, o sukcesach i zagrożeniach związanych z tą metodą. Kolejnym wykładowcą będzie pani profesor Barbara Przewłocka, która jest farmakologiem i światowej sławy badaczem mechanizmów bólu, opowie o mechanizmach i możliwościach leczenia, o nowych lekach w terapii bólu. Zaprosiliśmy również dwóch wykładowców spoza członków naszego wydziału. Będzie to pan profesor Andrzej Pająk, epidemiolog, który przeprowadził duże badania populacji polskiej i spróbuje nas przekonać do modyfikacji czynników ryzyka chorób sercowo-naczyniowych. Wreszcie ostatnim wykładowcą będzie pan profesor Rafał Ryguła, który zajmuje się problemami fake newsów, czyli atakujących nas ze strony internetu i innych mediów informacjami, które są niesprawdzone, a często rozpowszechniane w celu wywołania określonych nastawień społecznych. Jeszcze raz serdecznie zapraszam. Udział możliwy jest osobiście na tej sali oraz za pomocą przekazu elektronicznego transmisji komputerowej. Dziękuję.
Szanowni Państwo, Wydział IV Przyrodniczy Polskiej Akademii Umiejętności przygotował sesję o klimacie, przyrodzie i człowieku w antropocenie. Będziemy mówić o ociepleniu klimatu, o konieczności dekarbonizacji gospodarki w celu osiągnięcia neutralizacji klimatycznej do 2050 roku. Człowiek znacznie wpływa na obecne środowisko, stąd często mówimy o antropocenie jako współczesnej epoce geologicznej. Co się będzie działo z gatunkami? Mówimy o masowym wymieraniu i porównujemy te wymierania do tych, które były w przeszłości.
Tiru. Taki konkretny sygnał, który nigdy aż tak się nie pojawi oczywiście, bo wiadomo, go nie wszyscy mówią, ale to jest pałeczka z bliska, która wchodzi ci na stream.
Wymierania gatunków. Będziemy też mówić o tym, czy obrazowanie mózgu może nam coś powiedzieć o kondycji i przyszłości człowieka. Wykładowcami będą wybitni specjaliści z kraju i zagranicy. Serdecznie zapraszam na tą interesującą sesję.
Dzień dobry Państwu.
Good afternoon, ladies and gentlemen. My name is Marek Sanak. I'm a member of the Polish Academy of Arts and Sciences of the 5th Medical Department, and it is my pleasure to welcome you to the afternoon session, 150 Years of Modern Medicine.
Wspaniałych wykładowców. Plan jest taki.
We have great lecturers. There will be 3 lectures, then a short break, and then another 3 lectures, 25 minutes per each lecture. We hope for a lively discussion. We are not going to limit our discussion very much. I hope you will have some remarks or questions to our lectures. So the first speaker will be Professor Jerzy Kupiec-Węgliński, who has arrived in Kraków from California, where he works at David Geffen School of Medicine at UCLA Los Angeles, and he is a specialist on transplantology, and he works at the Dumont Transplantation Center, and he has presented a presentation on how to improve the quality of donor organs available for transplantation. There will be a lot of medical terminology. The presentation will be in English, so you can take a headset and you can listen to simultaneous interpretation into Polish.
Dziękuję, panie profesorze. Jest to wielki zaszczyt dla mnie tu być przed państwem i opowiadać o swojej historii, przede wszystkim o historii przeszczepów narządów. I jak państwo słyszycie, mówię po polsku zupełnie nie.
You can hear that I can speak Polish quite well, but I left Poland 43 years ago, and it will be easier for me to talk about my field of expertise in English.
Because I wanted to make it more interesting, not so scientifically focused, and we'll talk about where did we come from, where are we now, and where are we heading, paraphrasing the title of the Paul Gauguin's painting. And I tell it based on my, as I mentioned, 43-year experience of working in the field, starting, hard to believe, in 1973 in Polish Academy of Sciences, and then by pure accident ending up at Harvard in 79, just for 1 year. And this 1 year led to 18 years. And then, after 18 years at Harvard, I moved to UCLA on the West Coast. People still were asking me, how could you move from Harvard to UCLA? How could you leave Boston for LA? So I always thought it was midlife crisis. So anyway, UCLA is the largest solid organ transplant center in the world. And I tell it also because recently I was invited to become the chief editor for a global journal called Frontiers in Transplantation, where recently I wrote an article about grand challenges in our field. So this is kind of a sentimental journey back on memory lane, but with some thoughts, where are we heading? So, as some of you may know, the modern era of transplantation started at the Brigham and Women's Hospital in Boston in December 1954, where Herrick's brothers, one of them suffering from renal failure, got a new kidney from an identical twin. And the surgery and treatment was performed by those 2 gentlemen, which are on the right. And this is John Merrill, nephrologist, and Joe Murray. The bottom line is that they performed this kidney transplant, but then the reality kicked in, and when normal transplants were performed, not from identical twins, the outcomes were awful. Basically, we didn't have the immunosuppressive agents. The treatment was total body radiation, and the people were dying like flies. So Dr. Murray gave up organ transplantation, and he became a very famous and well-established plastic surgeon. And then out of the blue in 1990, the same person got a Nobel Prize based on this what he performed many decades earlier. So the take-home message is that don't forget about your experiments or your work which you did many, many years ago, because this may count to your benefit. So my time at Harvard started in '79. I was working in this center which started organ transplantation. I was collaborating with Nick Tilney, a dear friend, collaborator who then became the godfather of my only daughter. So it was a great time to work in organ transplantation because, again, I was lucky to be at the proper time, at the proper place, where the Jean-Francois Borel from Sandoz discovered a new magic powder, immunosuppressive drug, called cyclosporin. And Brigham was one of the 3 centers in Northern America which started to test this new drug, and my lab at the time was testing that, and this is a paper published in 1984. Hard to believe it's almost 40 years on the effects of cyclosporin in experimental settings. Then we collaborated with many centers, and the most fruitful collaboration was with Tibor Diamenstein from Freie Universität in Berlin, and with Terry Strom from Bethesda Hospital in Boston, where we designed the therapy against organ rejection, targeting the IL-2 receptor. And the idea was that if you target IL-2 receptor, all problems will disappear because it was in the center of the rejection cascade. However, the reality was not so great because when our findings from the experimental settings were transferred to the bedside, the results were not so great. But at that time, we are not aware that targeting IL-2 receptor, we are also targeting some T suppressor cells or T regulatory cells, which are beneficial. So by targeting IL-2 receptor, we were knocking down some of those cells which were beneficial. And many, many years later, knowing this from basic science immunology, we were able to move on the field, and now the IL-2 receptor targeted therapy is part of the immunosuppressive armamentarium, not only in organ transplantation, but also in other diseases. So now, then, in 1997, I moved to UCLA, and this is how UCLA looked like in 1950 when it was established. This is UCLA in 2000. In 2011, there was a new medical center, Ronald Reagan Medical Center, which opened, and this is the largest solid organ transplant center in the country. One of the pillars in organ transplantation from UCLA was Paul Terasaki. He's a major figure, and here are all his great work in organ typing, the description of hyperacute kidney rejection, and so forth. He was also a very shrewd businessman. He founded a One Lambda Incorporated company, which developed the plate to test immunogenicity of donor and recipient. To make the long story short, many years later, he sold the company for $700 million. And I remember vividly when he complained that he had to pay 200 million taxes. Okay, but he had enough money to establish his own institute, Terasaki Life Sciences building, and I was honored to be the inaugural chair in surgery of Paul Terasaki, and here is two memorable pictures with our chairman, the dean, and my family after getting this prestigious chair. So the first liver transplant in UCLA was performed by Ron Busuttil, who became the chairman of the department, and he headed the department for many, many years until last year. The first transplant was performed in 1984. At that time, there were 5 liver transplant centers in the United States. Now we have 148. And this is the record of Ron Busuttil and the team at UCLA, over 7,000 liver transplants since 1984. And the results are great, as you can see. I mean, these are the people who are dying. If they do not get the life-saving organs, they will unfortunately die. And if they're lucky to get the transplant, about 80% will live at least 20 years. In the pediatric cohort, in adult, about 60–65% will live 20 years. And these are some examples. Here in 1984, this little girl had a very, very bad liver, congenital biliary atresia. Next, this is the same girl after liver transplantation. In 2008, she got married. Here in 2011, she's surfing at Hawaii. Our center has developed in situ splitting of liver, which means that the liver taken from the cadaver sources can be cut. 1/3 is given to a child, and 2/3 is given to adult. And this is our first example of such a split liver transplant, where the child got a small piece and the adult got the larger piece of the same liver. And this is the first living donor case, which means that this dad gave a piece of liver to this child who was dying in 1993. Here is the same child in 2008 with the recipient liver, and both dad and the girl are fine. However, there are problems, and this slide illustrates the current status of liver transplantation. We have more transplants performed during the years. However, the number of patients on waiting lists increased exponentially. And here is the current status of liver transplant in the United States, according to UNOS data. Every year, there are about 16,000 patients who are waiting for life-saving organs, but only about 6,000 of those people are actually transplanted. And especially, I mean, there are about 1,500 who are dying, and because many of those people on waiting lists are too sick, so they are removed from the waiting lists. And what is also important is out of about 7,000 livers recovered from the cadaver sources, about 10% are so bad that they are discarded and never used. So the problem is the scarcity of organs. One of the themes of my lab at UCLA is targeting ischemic reperfusion injury, in Polish niedokrwienne uszkodzenie organu. It is a multifactorial process that affects graft function after transplantation. It causes about 10% of early organ failure and certainly contributes to acute shortage of livers. And this is kind of a vicious circle of events, complicated events, cellular, molecular, and so forth. And my lab tries to understand it and find the way of improving the quality of organs available for transplantation nowadays. And we have developed a quite successful platform of so-called organ rejuvenation. And we start with testing at the cellular level. This is what we think is important for preventing this vicious circle of events. Then we go to in vivo testing in small animals. We have a liver transplant model in the mouse. As you know, mouse is small. To make a liver transplant is quite challenging. We are one of 4 or 5 centers in the world which can do it. Then we go into the large animal model. It's primarily swine. And finally, we test the idea in clinical settings. So what's new? Until very recently, the liver from cadaver sources were stored in cold prior to transplantation because of the distance from organ harvesting to organ recipient. And it was Peter Friend from Oxford who developed a new idea of normothermic preservation. So this is normothermic organ perfusion, which makes perfect sense because liver is harvested from the cadaver and then put on this system and maintained on this system for many, many hours, which allow also to add some modalities to the perfusate in order to improve the quality of those organs. And a few years ago, when I was in Warsaw, I gave the interview to Gazeta Wyborcza, and this is the title of this interview, Wątroba odmładzana w spa. I like this title. The second idea which we developed, which actually is finding its way to the clinical setting, is use of neuropeptides in liver rejuvenation. And it's an interesting concept because the brain produces center transmitters which affect everything else in your body. And we found out that certain neuropeptides, so-called backup neuropeptides, may be very beneficial for improving the quality of organs available for transplantation. And actually this is patented and it's close to be used in clinical settings as well. The next concept is the microbiota. And this is very interesting concept. Microbiota is also called a hidden organ. And you need to realize that it is a diverse conglomerate of about 100 trillion bacteria. And each of us has about from 1 to 2 kilograms of mass of bacteria in our body. And if you think that it is 150-fold more genes than the human genome itself, it's obvious that it has to do something. And we performed many studies which were actually published in top journals, where we found out that the mice which are pretreated with antibiotics, if you give a proper antibiotic and in high dose, the organ transplants survive much better in those mice. And this was a very challenging concept. It took us some time to convince the reviewers that this really is a case, but we finally did it. And what is important is that the findings from experimental animals were confirmed in our liver transplant patients. And this is a complicated slide, but the bottom line is we had over 400 patients with after liver transplantations. And if those patients who got a high dose of antibiotics prior to transplantation, because they were very sick, they had encephalopathy and so forth, and if those patients got a proper antibiotics for a prolonged period of time, despite being very sick, their livers performed better than in patients without antibiotics. This is quite provocative, but this is true, and we continue those studies until now. So what happens here, there's an interaction between gram-positive and gram-negative bacteria, and certainly the gut microbiota composition change makes a big difference in the quality of organ available for transplantation. So, next is xenotransplantation. I used to be one of those who think that xenotransplantation has a great future and always will. However, we have the first pig-to-human heart transplantation, which was performed in Maryland on January 7th, and the patient, 57-year-old patient, survived over 2 months. It is kind of a breakthrough, because all xenotransplants which were performed so far from pig to subhuman primates survive minutes or hours. How did it happen? This was not a normal pig heart. There were 10 gene-edited pig. So this was transgenic pig, and as you can see here, there were many genes which were removed from this pig, and there were some genes which were knocked in, and I want to stress here the HO1 gene, which is the anti-inflammatory, cytoprotective, which my lab is very interested in, and as far as I know that Dr. Dulac's lab is also interested in this gene as well. So this is not a normal pig, it is transgenic pig, and I think that I may change my gut feeling that perhaps xenotransplantation will become the reality soon, especially that when we look into the histologic assessment of this heart after in this patient was tested, there was no real reason why this patient died, because if you look at the autopsy, there's no clear-cut rejection response. I mean, there are some necrotic cells all around. However, this is not a rejected heart. So we still need to learn more in this field, but hopefully xenotransplantation will become the reality for many patients needing the life-saving organ. Next, vascularized composite allotransplants. I am very much involved in that. On the left is Max Bernard, a very good friend who was unfortunately passed away last year. He was from Lyon. He performed the first hand transplantation and the first face transplantation. On the right is Maria Simonov, originally from Poznan, also a friend of mine, who performed the first face transplant in the United States. Let me tell you, this is not an easy area. Max's first human transplant, hand human transplant recipient, after many years, came back to him and asked to remove the hand because mentally he couldn't accept the fact that he is using the hand from the cadaver. So this is a complicated area. We don't know how to treat those patients because the VCA is very different from the solid organ. And this is some old work again from many, many years where my lab was using cyclosporin again for prevention of VCA transplantation in rats. Here you can see white rat with black leg transplanted, and here is white rat with transplanted black head. phase, and again cyclosporin changed the outcome significantly. This is our program at UCLA, which is headed by Cody Azari. UCLA is one of 7 hand transplant programs in the United States. Here is our first patient who received a hand transplant. This is the same person a few months after. Interestingly, she got hand transplant from a man, dead man, and in the beginning, the hair was starting to grow, but finally her hormones took over. Unfortunately, the immunosuppression, which was needed to maintain the hand in this person, was killing her kidneys, and unfortunately the hand had to be removed. This is another patient with hand transplant and liver transplant. So this opens totally new, different area. This patient is doing fine. And finally, the final frontier of organ transplantation, body-to-hand transplantation. And this is something which we need to keep in mind. Started with experiment in Russia of transplanting head of one dog to another dog. Nowadays, there are many centers in China who are doing similar experiments in rats. And here is Sergio Canavero, the Italian surgeon who is preparing to transplant the head. And this is potential recipient from Russia who calls himself a new Gagarin. Whether this will happen or not, we don't know. However, there are many, many papers in highly impacted journals which discuss that issue. Here, surgical, ethical, and psychological considerations of human head transplantation. From its hysteria to hope, the rise of head transplantation. The immunological consideration in human head transplantation by Mark Hardy, one of the pioneers of solid organ transplantation. So many, many years ago, actually 20 years ago, when I was very proud to accept the honorary doctorate of my old alma mater in Warsaw, I gave the interview to Kulisy, where I stated, nie chcę doczekać Frankensteina. So, how many body parts can you exchange and still think of yourself as yourself? Lub ile części ciała możesz wymienić i nadal myśleć o sobie jak o sobie? Dziękuję bardzo Państwu.
Serdecznie dziękuję panu profesorowi.
Thank you very much, Professor. I guess there is still time for one question or perhaps 2 questions. So visa issues and challenges which can be solved, so ethical issues, various implications. If you have a question or a remark, please raise your hand. I will approach you with the mic. I know the person who wants to ask a question, Dr. Krzysztof Szade. Should I speak English or Polish? Up to you.
I will ask you. We all know, and you perfectly shown this, that the immune response is our main foe in this organ transplantation. What is your opinion on resetting the immune system by conditioning and bone marrow transplant from the matched donor? And by this way, we can reestablish hematopoietic and immune system that will tolerate both the organ transplanted and the own body.
Well, I mean, so-called reconditioning or reprogramming of the host has it may be certainly considered. I mean, many years ago we used so-called immunological enhancement by treating prospective recipients of organ transplant with the immunological serum of the donor. So this has been done, and certainly, I mean, this kind of conditioning is very logical, especially in terms of in the settings of liver transplantation, because I come from the liver world, so liver is considered to be less immunogenic than other organs. We still don't know why, but because it's so large, and contains so many hematopoietic cells, liver itself, when transplanted with other organs, may tolerize kidney transplant recipients or heart transplant recipients. So this is definitely, there are many combinations which can be considered in order to achieve this holy grail, as we call it, of immunological tolerance.
Dziękujemy. Profesor Brzozowski.
That's just fantastic presentation. I would like to ask you about once discussing conditioning, then preconditioning, originally discussed by Muri maybe 2 or 3 decades ago in dogs. This small ischemia might be having some beneficial effect against ischemia reperfusion injuries. So it is still the way we can use it in the clinic.
Yes, absolutely yes. And this kind of improving the outcomes by conditioning of the organ with a short period of ischemia, it really works. It's even in the clinical settings, and it may relate to the fact that the stress induces some beneficial effects in order to promote immunosuppression and to improve the outcomes by improving the function of the organ. So this is absolutely a valid point, and this kind of experiments are done not only in experimental animals, but also in humans as well, especially in the liver.
Dziękuję bardzo. Przepraszam, że przerywam dyskusję.
I'm sorry to cut in, but we have to be on time. Professor will remain with us for the rest of the session. He will be with us during the break. So if you have some ideas how to improve transplantology, he will be ready to talk to you about that. Now keep your fingers crossed, because the next speaker is over here.
W Kanadzie, w Saskatoon.
So marking is Canada right now. Professor Marek Radomski, he will be speaking from Saskatchewan, and he works for the Medical University of Saskatchewan, and he would like to share with us triumphs and challenges of science. So I think it will be a very interesting contrast between Poland and Canada. Marek, thank you so much. Can you see my screen and can you hear me? Okay, we have your screen too. So you can hear me well. Can you hear me well? Can you hear me well? All's well. Fire away. First, I would like to thank you for inviting me here. It's a great honor. I wish I could be with you in person because I graduated from the Jagiellonian University and Collegium Medicum. I would also like to have my presentation in English. And at the end of the presentation, I'll be happy to take your questions, both in Polish and in English.
Science, and this is actually the aerial view of our University of Saskatchewan in Saskatoon. First, let me start from acknowledging that our University of Saskatchewan is localized on a land of living sky that for centuries have been looked after by First Nations and Métis people. I have nothing to disclose when it comes to this presentation. I will be using the publicly accessible data and sharing with you my experience in the Office of Vice Dean of Research with COVID-19 that I lead. This is the virus, the pathogen that causes the disease, a small particle, not larger, usually than 100 nanometers. What is characteristic for this virus is the presence of the many spikes on the surface, protein spikes, and this is, as you know, the coronavirus, the virus belonging to this family of pathogens. And the spikes allow the virus to actually latch to the target cells. And the big problem that we have been facing over the last number of years is a number of months is that there are many mutations associated and present in a spike protein. So when you look at the pathophysiology of the infection early on, the virus has the ability to attach itself to the cell. It latches to the cell through the interaction with ACE2 receptor, angiotensin converting enzyme type 2 receptor in the presence of transmembrane protease. The virus enters the cell and releases the cargo, and the cargo is its RNA. Once the process progresses in the early stage of infection, the virus interacts both with the epithelial, pulmonary epithelial cells and has the access to alveolar capillary. As a result of it, it causes the white cells to come and our immune system to basically try and to attenuate the infection. However, when the infection is not stopped at this time, the late stage COVID-19 reactions proceeds. This is the chronic inflammatory reaction with increased vascular permeability, leading to a generation of the fluids and the hyaline membrane formation within the alveolar space. The very dramatic situation is the formation at this time of the pulmonary thrombi. And this is the most dramatic part of the infection, when the lung becomes completely destroyed with the numerous thrombi present on a pathological examination. We've been dealing with the virus for the past almost 3 years now. First, the previously circulating variant of interest as classified by WHO were alpha, beta, gamma, and delta. And they were documented in 2020, initially in the UK, then South Africa, Brazil, and India. Now we are dealing with another unwanted guest, and a currently circulating variant, and this is the Omicron. Omicron has already, over the past year, managed to produce a lot of mutations. And some of these mutations and the subvariants, sublineages are already present if you log on to the WHO website. And probably still the most predominant sublineage and variant is BA.5, that in a month from September to October accounted for a little bit less than 70% of the infections within the United States. In red frames, I denoted the presence of BA5 and also a very interesting and troubling sublineage called XBB, which is basically the product of the recombination between the different variants of Omicron. So why Omicron is so troubling? It's because of its stealth and cunning. You probably are all aware of the stealth aircrafts with the Ukraine war ravaging. We know about the stealth aircrafts. This is actually the one flying over the mountains in Nevada. the characteristics of this jet fighter is that they are not seen on a radar screen. And Omicron, indeed, through its mutation, caused this stealth-like reaction. Our immune forces are basically not seeing properly the Omicron because of these mutations on the surface, and the virus can evade the immune attack. The other thing is it's cunning. It's a very cunning virus. It can also increase the stability of its spikes. As a result of the increased stability, virus can persist in itself for longer. And that's probably the last characteristic which sets apart Omicron from the older variant. As I mentioned, the older variants needed the two proteins to enter the cell, ACE2 receptor and the serine protease. Omicron does not need the proteolytic reaction to enter the cell. It just latches to ACE2 receptor and proceeds intracellularly. When you log on to the WHO COVID-19 dashboard, what you would realize that over the time of pandemics until 4th of October 2022, across the world, we had 619 million of confirmed cases, with more than 6.5 million of fatalities across the world. For the purpose of this presentation, I would like to home on these epidemiological situations in Poland and Canada. This is not unwarranted comparison because the population of two of our countries is almost identical. The Poland almost 38 million and the Canada 38 million. The differences are, of course, the vast size, territorial size of Canada as compared to Poland. The differences are also that in Poland, we've got 15 million of population residing in the rural areas. It's 7 million in Canada. The Canadian GDP is on average 3 times bigger than the Polish GDP. However, most of the Canadian population resides within the 100 kilometers from the US border. So it's a very concentrated population in agglomerations such as Toronto, Montreal, Vancouver, or Edmonton. So this is just a direct comparison coming from our World in Data websites that uses the various sources, including Johns Hopkins database. And what this graph shows is that there have been a big difference in daily new confirmed COVID-19 cases between Poland in green and Canada in red, particularly in the early stages of the pandemics. Cumulatively, Poland has suffered with more than 6 million confirmed COVID-19 cases, Canada more than 4 million. Probably one of the most dramatic index of the advancement of the pandemic is hospitalization. And again, you see here the big difference with Poland experiencing huge hospitalization due to COVID-19 and the Canadian hospitalization much less. Mind you, in both situations, in Poland, we had a huge overwhelming of the hospital system, and we had also the problems within Canada and indeed within our province. So hospitalization, unfortunately, leads to death. And again, you see the differences between the Polish situation, the big spikes, and the Canadian situation, smaller spikes. Cumulatively, when it comes to COVID-19 deaths, we have around 118,000 deaths in Poland, and we have around 42,000 deaths in Canada. If you normalize the death toll, and this is the concept of excess mortality, the percentage difference between the reported number of weekly or monthly deaths in 2020-22 and the projected number of deaths for the same period based on previous years. This difference between the excess of mortality in Poland and in Canada is very striking. Now, this inversely correlates with the number of vaccines administered. We had quite a big campaign within Canada for the vaccination, and this slide shows you the daily COVID-19 vaccine doses administered over the course of pandemic to date. Totally, cumulatively, almost 83% of Canadian population has been vaccinated at least once. And this is when it compared to Poland is less than 60%. World average is around 63%. Now, the vaccination, as far as I am concerned, and the development of COVID-19 has been a really triumph of science. Imagine 3 phases of vaccine development under 1 year. I remember lecturing for so many years to our students the process of the new drug entity development of vaccine takes years. This has been actually within the 1 year through the operation nickname a warp speed operation of warp speed. And this is just the timelines. In December 1st, 2019, the virus, the first cases in China, presumably first cases in China, and then December 11, the following year, US FDA grants first emergency use authorization for the Pfizer vaccine. Our times, our lives to date since March or earlier 2020 was like a ride on a roller coaster. The question is, are we towards the end of this ride? Is the COVID-19 pandemic over? Socially, most likely, yes. I mean, people are less and less willing to obey the rules of regulations of pandemic behavior. Politically, yes, we had a mighty of this world like President Biden declaring the end of or almost end of the pandemic. Epidemiologically, absolutely not. This is just a joke. What part of COVID is over does this kid not understand? It's definitely epidemiologically, we've got the strong evidence, and unfortunately, we have given up with COVID, but the COVID hasn't given up with us. First evidence, we've got the situation in Singapore, in Asia, most likely carried by the XBB, this recombinant variant. The best way, and I haven't been talking really about the monitoring for COVID-19 infection, but probably population size, the best way to monitor the situation within our communities is wastewater monitoring. This is actually the latest graph produced by the Global Institute for Water Security at University of Saskatchewan. And unfortunately, as you see, we are experiencing now increased load of the viral RNA in wastewater, indicating that we are bracing ourselves to a new wave. So what would winter 2022-2023 bring to us? This is a little bit like looking into the crystal ball. A number of very high-profile virologists, immunologists have been wrong, predicting the end of the pandemics while the virus has been incredibly active in its replications. So I would not look classically through the crystal ball, but I would present you 3 possible scenarios. The best case scenario is, of course, a small wave. This will be most likely if the Omicron chooses to stay dominant and our population immunity through the natural infection or through strong booster uptake, I'll be happy to talk about the boosters, will increase. The worst case scenario is the emergence of more deadly variants, such as XBB, that will take over after from BA.5 and become dominant with more deadly effects. Probably the most likely scenario is average type of scenario, mild wave with regional outbreaks. I am the eternal optimist, so I hope we will experience during this winter an average case scenario. The last 2 minutes, I would like to talk to you about the response of the office. I lead Office of Vice in research in front of the pandemics. What my office does, with the help of a number of great executives and the 2 people who helped me in administration, Megan Truscott and Eric Lukong, we provide the service for our faculty and students. We look after basic clinical population research studies. We also administer the clinical trial support unit, and of course, we help our grad students. We have been doing it over the last 6 years, and certainly during the course of pandemics, having rolled out a number of faculty supports. We have rolled out 23 different faculty support initiatives. We have gone through the very dramatic, very intensive way of activity. First, in literally 48 hours, we had to suspend almost 90% of our research because of the lockdown, then resume, then go on to resume research, increase the communications, modified our initiatives, and come up with the new initiatives. What I think has been the most rewarding for us is the possibility to recruit early career researchers. I call them young wolves to our universities. Over the time of pandemics, we recruited 11 absolutely talented young researchers since 2020, and they've been very busy writing the grant and coming up with the great number of very prestigious Canadian national and international grants. And this is just the reflection of this activity. We suffered the dip in our research output due to pandemics, but we are now very handsomely coming out of the situation. So I'm happy that despite all the calamities around us, we are doing well. Finally, over the last 20 minutes or 22 minutes, I was talking about the plague made by 100 nanometers inside virus. Absolutely unbelievable plague is the one launched by Putin Russia. People like Putin, butcher of Syria, Dvornikov in the past, and Heichmans. The Russia has launched Ukraine war and is spreading geopolitical terror across the world. I stand for the Ukraine. Slava Ukraine. Glory to Ukraine. I'm happy to take any questions in both languages. Thank you.
Dziękuję bardzo, panie profesorze. Dziękuję, Marku. Teraz na...
Thank you very much, Professor. Thank you, dear Mark. I hope that before our transatlantic connection is cut off after your political declarations, we'll get some questions. I'm from the Jagiellonian University Collegium Medicum professor. In Poland, in 2020, we had about 70,000 of extraordinary excessive deaths. And these deaths were closely coincided with the second and the third wave of the pandemic. And only 1/3 of these deaths were clearly caused by COVID. Other deaths were caused by other causes. The highest growth in that morbidity was caused by diseases of the respiratory diseases, circulatory diseases. So, do you have any reason why there were deaths caused by such diseases? I thank you very much for this question.
Jest kilka różnych czynników, które za to odpowiada. Czynnik pierwszy jest, że z powodu lockdownu
So for one, because of lockdown and patients with cardiovascular diseases, well, they were reluctant to look for help. I heard from our cardiologists, our MDs, that people were coming very, very late. And that's one thing. Another thing is that one of biological targets of this virus, is the cardiovascular system. We have very good proofs for that. We know that the virus destroys endothelium and causes
nie miałem czasu, żeby mówić o fenomenie, który nazywa się po angielsku long COVID.
And I didn't have the time to speak about long-term complications And one of the theories, well, this is one of the issues that is going to aggravate in the process. Most likely one of every fourth person falling ill with COVID may experience long COVID, and one of the one of the classic theories of COVID is this with the symptom of brain fog, inability to focus, and disruption of coordination, and that is likely to be caused of the microembolism in micro cells. So I think these are at least these two basic factors. And the next factor is that in terms of in epidemiological sense, cardio diseases, vascular diseases, these are diseases that increase patients' risk. So it's a combination of factors. I know that when it comes to quantitative data, it may be as well that a patient is admitted and tested, and the patient is admitted for because of one reason, and it turns out that he's already infected with COVID, and then the impact of the virus on the patient remains to be identified. Professor Marek, thank you so much. Stefan, well, good to hear you. So when I hear an expert speaking about mycothromby and about cardiovascular diseases, I cannot stop myself from asking why anticoagulative treatment in such patients is not effective. Anticoagulation with anticoagulative medicine drugs, it is a standard and improves survival. So my question is about the best combination. So with COVID, we have clots, we have activation of circulation, do you have any explanation for that? No, I have no explanation for that. Not really. It's as simple as that, but epidemiological data about coagulation are as follows, or anticoagulation. Depending on the publication that you're going to analyze, heparin in life-threatening situations when COVID caused such a massive clogging is applied, is used, but for preventive purposes. Unfortunately, there are no population-based data or evidence, as you were saying, Stefan, that application of the drugs that you mentioned antiplatelet drugs, ephedrine-rich
nie można stosować profilaktyki z lekami przeciwkrzepowymi. Ja znam wiele grup, które są zainteresowane
here. I don't think it would work. I know groups that would be interested in that, but the question is why antiplatelet drugs that should be counter-effective do not seem to do the job.
And I'm really surprised that answering the previous question, the question considering the growth in a general death toll, you didn't point to the very important factor of general decrease of level of public healthcare in Poland. That
I did do. I mentioned that one of the reasons for increased mortality is that the patients suffering from the different diseases like a cardiovascular disease are either not registering, not coming to, or they didn't have an opportunity to come to.
Exactly.
I am not an expert from the Polish situation. I haven't been during the time of the pandemics in Poland. So most likely you are right. Most likely you are right. It's the funding of the health service in Poland is not as it should be. Comparatively, Canada has the GDP, consequently health funding much higher.
Highly evaluated.
Oh, I completely agree. The way how we can treat any patients, including COVID-19 patients, is very much dependent on the strength of the health service available to all patients.
And accessibility. Dziękuję bardzo. Dziękuję, Marku. Wspaniała jakość.
Thank you so much. Excellent quality of this connection and excellent presentation. Thank you.
Proszę Państwa, i trzeci wykład przed przerwą. Mój kolega, pan prezes.
And the third lecture before the break will be delivered by Professor Józef Dulak from the Faculty of Biochemistry, Biophysics and Biotechnology, my colleague from Jagiellonian University. Somehow, once again, it is a hot topic. Prospects for medical biotechnology, genetic therapies and stem cells.
Therapies and stem cells. Zapraszam.
Dzień dobry Państwu. Bardzo dziękuję za zaproszenie, Panie Prezesie.
Thank you for the invitation, moderator, ladies and gentlemen. It is a great honor for me to be a speaker here at the medical faculty. Well, I've been for more than 10 years. I'm a member of the medical department, even though I'm a biologist by education, and it is all thanks to Professor Andrzej Szczeklik. Several years ago, he got interested into our research, especially about oxygenases, mentioned by Professor Kupiec-Węgliński, and that is why I am today here. I've prepared a lecture in Polish, but there was...
minut, no troszkę mam nadzieję, że uda mi się skrócić.
All right, I will try to be brief. I have just 25 minutes. I have written a text.
I w związku z tym no, czasem będę zerkał do tych kartek.
So perhaps I will read certain passages from the prepared text. Professor Litwinienko and Professor Juskowicz have touched upon certain topics that I wanted to discuss. So perhaps there will be some repetitions, but I hope you will forgive me. The beginning of modern medical biotechnology is connected with pioneering experiences like Edward Jenner's. It was mentioned by Professor Alicja Juskowicz. Let me just mention very briefly that these experiments were carried out by Jenner in a way which wouldn't be acceptable at the moment, but it was at the end of the 18th century. These were disruptive and breakthrough experiments, so he proved that you can immunize human body against a virus of smallpox. He didn't know it was a virus, obviously, but this event is considered to be the beginning of modern vaccinology and modern biotechnology. The 20th century, smallpox was fully eradicated and vaccination saved lives of hundreds of millions or perhaps even billions of people. So it is a spectacular example of achievements, and SARS-CoV vaccination is an example of similar achievement. Clinical trials were carried out very fast, but they were very reliable. It doesn't mean that they started at the beginning of the pandemic. The tools which were used to prepare vaccination were previously studied and were very well known. applications of medical biotechnology. They are connected with development of genetic engineering, manipulation of nucleic acids, DNA, genetic material of living organisms, viruses, and RNA, which is a genetic material of SARS-CoV-2. Recombined human insulin mentioned by Professor Juskowicz, created in bacteria or other biopharmaceuticals, in yeasts or mammals, are just some examples of impressive achievements of biotechnology. So, thanks to medical biotechnology, you may use monoclonal antibodies, apart from genetically modified cells, for production of drugs. They use GMO animals, like transgenic goats, creating thrombin, antithrombin. So the medicine is called Atrin. Medical biotechnology is also about plant biotechnology and using these tools to obtain golden rice, which is the rice with precursor of beta-carotene, so precursor of vitamin A. So it is a great benefit, but we know this benefit and this gain and achievement is not always welcome by the general public. And because my lecture is supposed to be very brief, so I can't discuss various biotechnological achievements at length, but as Professor Sanak has mentioned, I will focus on stem cells and genetic therapies, gene therapies, because these are highly interesting topics, but people get emotional while discussing them. We could avoid them if they are understood correctly, but I hope certain issues and challenges will be solved soon. So we have fertilization when we talk about developments of a body of a mammal. So insemination cannot be always done organically or traditionally, so you may improve some processes. So Patrick Septo and Robert Edwards came up with in vitro fertilization, and they received the Nobel Prize in 2010. It is among the greatest medical achievements and medical biotechnology achievements that gave life to a few million of healthy kids without any diseases and problems. And these are kids who brought happiness to millions of parents. A zygote is totipotential cell, so it gives rise to all other cells and also to placenta. Professor Litvinenko has mentioned that before. When zygote is divided, we have blastomers, then blastocytes, and then we have development of a full body, which includes, as you can see here, 200 types of various cells. And it all begins by fertilization of an egg. And thanks to in vitro techniques, which were mentioned by Professor Litvinenko yesterday, studied in mouse and then applied to human embryos, scientists since 1997 have human embryonic stem cells, and these are the stem cells discussed yesterday by Professor Litvinenko during yesterday's lecture. These ESCs are obtained from embryonic node, and for the first time in humans, they were obtained by James Thomson. These ESCs are pluripotent cells, so they may create all cells of the body, but not the placenta. It is the difference between blastomers, which are totipotent. During the zygotic development, stem cells create 200 types of cells, building tissues and organs. Some of them are transformed into stem cells typical for organs. During development, stem cells lose the differentiating potential and become either multipotent or so the ones which give rise to several kinds and types of cells, but from one leaf. So multipotent are stem cells which are hematopoietic cells in bone marrow. So one hematopoietic cell is differentiated to various blood cells, but it doesn't have a possibility to be differentiated into bone cells. They may also have a more limited potential. They are unipotent, like the ones which appear in skin. They differentiate only into epithelial cells, and there are satellite cells which regenerate our muscles, like skeletal muscles. Stem cells are divided into self-renewal process. What is typical of stem cells is an ability to self-renew and to differentiate into specific kinds of cells. So regeneration of organs may happen. So not the size, shape, or location is decisive whether these are stem cells. No, it is their function. It is of paramount importance in a healthy human organism. There are no pluripotential cells, but the potential of adult stem cells is huge. In one day, on the basis of hematopoietic cell, you may have hundreds of billions, various types of blood cells. We may study them, we may check them, how they can differentiate. You can see that in the publication by our team, which shows the colony of cells from one hemipoietic stem cell in a mouse, and the other photo shows types of cells which were created on the basis of this initial hematopoietic stem cell. Stem cells appear in various organs, but not all of them. They are in bone marrow, skin, intestine. But we don't. But we don't have them in all the organs of our body, so they may regenerate damaged muscles in the skeleton, but we don't have stem cells in our heart. We have stem cells in the front parts of our eye. We call them cornea limbus. And they may regenerate the cornea, but we don't have them at the back of our eye. We don't have them in our retina. That is why therapy of various kinds of blindness is so difficult. So here we can see the difference between various parts of our body. But if we select stem cells in the right way, it can be very helpful to hundreds of patients. You may think about transplant of bone marrow. It may help burnt patients because we may, for example, grow on the basis of the stem cells. So you know, actually, Justyna Drukała and her team and her and stem cells may be used in the holocular method using corneal limbus, which regenerate the damaged limbus of the cornea. So stem cells have a potential, but it is limited. So it is not true that any cell arbitrarily called stem cells can be used to treat different diseases. So hematopoietic stem cells do not regenerate bones. And bone marrow multipotential cells, which are precursor to skeletal or bone or fat cells, do not have an ability to regenerate blood cells. The same reservation is true for other cells, which are only called stem cells. They are really not that. There are no proof that if it is from wharton jelly or if they are from fat, they do not have special ability to differentiate. They cannot treat autism. They cannot treat spinal muscular atrophy or dozens of diseases that you may have heard of. There is no proof, there is no biological foundation to use these cells for everything or to treat everything. But what happens if there are severe diseases for organs where there are no stem cells? So you don't have it in heart, in brain, or in some parts of the brain there are stem cells, but there are no stem cells that would regenerate cortex, for example. What happens then? In justified cases, you may try to use pluripotent cells, like embryonic stem cells, differentiate them in the lab to cardiomyocytes, and then apply them to patient. Pluripotent cells cannot be injected into the body because if they are not differentiated, they will not be helpful. They may create teratoma. So such attempts
wykorzystuje się w próbach eksperymentalnych, uzasadnionych próbach leczenia choroby Parkinsona. W pierwszej kolejności, tak jak Państwo...
So, as you may have noticed, scientists use embryonic stem cells, but their application is limited, also for ethical reasons. For the last several years, we have an additional source of pluripotent cells. It was mentioned by Professor Litvinenko yesterday, thanks to the method prepared by Professor Shinya Yamanaka, who together with Sir John Gurdon, received the Nobel Prize. Yamanaka showed that it is possible to transform a differentiated fibroblast or fibroblast, where he started, but now you use leukocytes, so white blood cells, and these cells, after reprogramming, which is about expression of 4 genes, which is Yamanaka's cocktail. After several days, they are transformed into small cells that Yamanaka calls induced pluripotent stem cells. These cells have a capacity, as you can see in the slide, to be differentiated into various types of cells. And in our studies in IPS, we differentiate these cells to skeletal, muscular cells. It is difficult, but it is easier if they become cardiomyocytes or epithelium cells. Cardiomyocytes from IPS shrink, so it means they have electric potential like cardiomyocytes. We also use these tools to have 3D structures called organoids. It was said yesterday that this is a very good tool to study mechanisms of diseases when diseases pertain to hearts, and these studies are about cardiomyopathy in Duchenne heart dystrophy, which is very difficult to treat, affects boys, and you can't study heart cells directly from the patient, but you can reprogram blood cells. Perhaps in several years, or even before that, or maybe later, IPS will be used in treating heart failures, as we showed in our studies, where cardiomyocytes obtained by IBS reprogramming, and we also study a possibility to improve their function via increasing expression of certain genes like oxygenases. And we showed in our studies that human cardiomyocytes to mouse, which were given heart infarction, so if these mice were deprived of immune system after heart infarction, heart function goes down, so the applying cardiomyocytes improves the condition. It takes time, but definitely cardiomyocytes are there in the heart. You can see it in this photo. Now, The other part of my presentation, gene therapies or genetic therapies in a broader sense, and in their functional definition, they are about regaining the right gene function by means of specific drugs, which are nucleic acids. And it may be the right mutated sequence in patient or other RNA or DNA particles applied directly to the genetic material. It is the original version of the gene therapy, so introduction, the right copy of the gene, the mutation of which led to a disease in patient. The right gene is introduced by means of a vector, so they reach the nucleus of patient cells and the gene is expressed there. A protein is created and cells produce the missing protein. How does it happen? What may be the results? If you allow me, I will discuss a brief history. So there was parents' happiness initially, but then there was tragedy and concerns because a little infant was suffocating and had problems with holding her head and swallowing, and the diagnosis was SMA, spinal muscular atrophy. And the same woman was pregnant again a few years later, and there were additional tests done, and again mutation was inherited by the embryo again, but the mother decided to give birth because there was a chance for treatment in the United States. Clinical trials of AV vector, so clinical trials started with the correct copy of the mutated gene, which is mutated in SMA patients. After giving birth, Evelyn, this little daughter, little girl, received an intramuscular injection, so the science can change what had been unavoidable in the past. So gene therapy saved her life. You can see this photo of smiling Evelyn, and FDA in the US was thinking about registering of Zolgensma as SMA gene therapy. It is available since June 2019. So it was added to nusinersen, previous drug. So it is the drug which enhances the correct expression of SMN2. The result is the same, but mechanism of these drugs are different. Nusinersen regains the right expression, but normally it is non-functional gene. It is not necessary when SMN1 is operating well, but when it is mutated, a method of oligonucleotide is prepared and it regains the right expression as SMN2. Zolgensma is refunded also in Poland. It is available for infants with the most severe SMA. Not all the results in children with SMA were spectacular, like in Evelyn's case, yet Zolgensma is efficient in SMA therapy. We can say that thanks to medical biotechnology studies and research, this drug is available. So we have Zolgensma and nusinersen, and the most recent is risdiplam, which is a small molecule compound, and it works more or less like nusinersen. Thanks to determination of Polish pediatric neurologists supported by patients' organization, nusinersen has been refunded for 4 years, Zolgensma for more than a month, and what is of great importance, it was diagnostics was implemented in all infants in Poland. So if mutation is found out, treatment may start even before any symptoms appear in young children. It is very important to start treatment before symptoms appear. 900 people are being treated at the moment. So it is very important for all of them. And new patients can be also treated with Zolgensma. In the past, they were only treated with nusinersen, and now SMA patients can be treated. So I want to praise pediatric neurologists. All of them were very much involved, and they were very strongly supported by patients' organizations. Gene therapy has longer history. It goes back to the beginning of the 1960s, where DNA was decoded and genetic code was decoded, and it is common for organisms and viruses. In 1962, pioneering studies showing a possibility of genetic modifications in mammals were published. They were carried out by Professor Wacław Szybalski, a foreign member of our academy, and he was awarded for that 50 years later. So in 2012, after his pioneering research, so these were tests and research and studies by Wacław and Elizabeth Szybalskis. And thanks to that, diseases could be later on treated by means of gene therapy. So it is all thanks to Professor Szybalski. There were also John Gurdon's study, and Shinya Yamaniaka later on continued this research, but actually he was born in 1962. Professor Szybalski had a very interesting life. It was described by Jarosław Abramow. Neverly, it is available in Polish and English, so if you are interested in that, you can read more about Professor Szybalski. So that method of gene transfer in the next decades was replaced by more efficient gene carriers, and these are modified viruses deprived of disease-generating capacity, but they give their genetic material to cells, and thanks to that, we may use viruses to provide therapeutic genes. So virus and virus vectors are used. Non-viral nucleic acids, plasmids, or particles of RNA are also used. In gene therapy for SMA, therapeutic gene that I've mentioned is applied directly into the patient's organism intravenously by injection of the vector, a different AV vector with the correct version.
A
different AV vector with the right version of the gene. It has to be the specific gene here. Is applied in patients with Leber's blindness who don't have the correct gene, and the vector is applied to retinal cells. It is a method that has been registered. In August this year, European Drug Agency decided that the vector with AADC can be also applied in patients who suffer from deficiency of this enzyme. It is applied by Professor Bankiewicz, foreign member of our academy from the University of San Francisco in Ohio, and this drug is applied by Professor Dankiewicz in cooperation with Professor Mirosław Ząbek in Brudno Hospital in Warsaw. They are confirmed and registered gene therapies, which are in vivo therapies applied in speed immunity deficiencies or some tumors or some cancers. Then you can repair hematopoietic cells in patients, and they can regenerate immune system. In CAR T therapy used to treat some cancers, there is T lymphocytes, which are taken from the patient, modified, given back to the patient, and they destroy the cancerous cells. 60 years after pioneering studies by Szybalski, gene therapy is well-established therapy. It is his heritage due to his visionary approach. Gene therapies are approved to be used in several kinds of illnesses mentioned in this slide, like hemophilia or beta thalassemia, and there is a chance they may be applied in more cases because plenty of studies are being carried out. I'm almost wrapping it up, so I just wanted to say something about the most spectacular case, namely experimental method used by Italian and German doctors in 6-year-old Syrian boy, Hassan, who suffers from hereditary epidermolysis bullosa. So this kind of EB is caused by the lack of the correct gene. So you don't have the right protein, and its shortage lead to the situation that people fall ill with EB. It is a lot of suffering. It is lack of defensive barriers, so it may lead to severe infections. So, for example, he had to undergo induced coma to be treated. So a fragment of skin was taken, and stem cells were grown by means of retrovirus. The right gene was introduced, and the cells, after being repaired, started to divide. And here you can see that they created the healthy epidermis, which was then grafted on his skin. And you can see the photo 2 years later. So you can see he's in very good health condition, and he remained healthy after 5 years. Graziella Pellegrini, one of the authors of this method of treatment, I know that he's still healthy, he's in good health condition. So this example is a justified attempt to provide therapy because it was well grounded. Previously, there were years of research and studies and initial clinical trials. It is an experiment which used the right stem cells, which can regenerate the right organ. Experiment carried out in line with scientific standards, ethics of medical doctors. Unfortunately, in many countries of the world, including Poland, people talk about miraculous drug. It is not justified because people call stem cells the cells which are not truly stem cells. So actually, this phrase stem cells loses its original meaning. It becomes like a holy grail, which is changing an average liquid into miraculous potion. So it is also used to attract desperate patients and parents of suffering children. I don't have time to have a lengthy debate about that. Let me just mention that there are various opinions of various institutions. They are also published in Polish. The Committee of Biotechnology of the Polish Academy of Sciences. I've been a member of that for many years. As early as, well, 10 years ago, pointed out that there are problems like that. In 2019, we published a special position warning against unjustified and unfounded therapies. There were various warnings from international bodies. After our position was published, the warning from applying unjustified therapies was also published by European Drug Agency. There was a drug of the European Academy of Sciences. Medical academies warned against such unfounded therapies. FDA warns against that, among other things. So you may have a look at these publications. There are various messages and publications, articles. There is also a webinar organized by the Polish Academy of Sciences in November 2021. All the lectures, the whole webinar are available at the website of the Polish Academy of Sciences. You may read a text by Paweł Walewski in Polityka, December 2019. Adam Socha, various scientific journalists write about that. Someone may say that revealing such problems and revealing such pathologies may actually undermine the foundations of science, because people may start believing in non-scientific solutions. But no, I'm of the opposite opinion, because what is of paramount importance for us is the good of the patients, but we also take care of the good of science. That is why we need reliable science, evidence-based medicine. So the Chief Council of Doctors has published the following position, warning against unjustified and unfounded experiments called therapies. So science can be efficient in treating diseases. Thanks to sciences, people live longer, healthier lives. Medical biotechnology has a contribution to this process. Thank you very much for attending.
Dziękuję panie profesorze, dziękuję za apel, ponieważ raczył...
Thank you very much, Professor. Thank you. Well, you've consumed... you haven't consumed all your time allotted for this slot, so I invite you to ask just one question. Is there any question?
Yeah.
My question is about the research conducted by Professor Pellegrini. Where was that? Professor Pellegrini, she works in Italy. This is a clinical team in Modena, Italy. And actually, there are Polish ophthalmologists who work with Professor Pellegrini. Polish patients, they have a similar issue. So, if these patients still have their limbus cells in good working order, so they're then used and reapplied to patients, but that is Italian research. Ladies and gentlemen, thank you. So let us start our planned break. I apologize for my lack of discipline. So let us meet again 10 to 4. So that is 3:50. Let us have some coffee. Let us refresh ourselves, because we have extremely interesting papers. Thank you.
Rafałowi.
Już wiem, musi być aktywne przeźrocze, ale tym pierwszym.
Nie. Wolne wszystko. Ja im dam znać, że już zaczynam.
Może zejść, żeby tak nie.
Nie. Świetnie, mamy dźwięk. Szanowni Państwo, rozumiem, że kawa była bardzo dobra, ale też istnieje obowiązek naukowy, pozwalając wejść dyskretnie wszystkim spóźnionym. Może przypomnę, że stare księgi religijne zresztą ostrzegały nas, że będziemy rodzić się w bólu i cierpieniu i tak się będzie toczyć nasze życie, ale to, co za chwilę Państwo usłyszycie od pani profesor Przewłockiej, ono doskonale przeczy temu, ponieważ postęp w dziedzinie
Mamy nadzieję.
Rozpoznawania przyczyn bólu, zapobiegania, nowych leków, układów odpowiedzialnych za odczuwanie jest fantastyczny. W związku z tym przedstawiam panią profesor Barbarę Przewłocką z Instytutu Farmakologii Polskiej Akademii Nauk, której prezentacja zatytułowana jest Ból, endogenne opioidy i poszukiwanie nowych leków. Zapraszam.
Dziękuję bardzo. Witam Państwa. Czuję się zaszczycona możliwością powiedzenia paru słów o naszej około 20-letniej pracy nad poszukiwaniem nowego leku. Jak się podejmuje tematu bólu, to zawsze trzeba mieć na uwadze to, że wszyscy słuchacze doskonale wiedzą, o czym mówimy. To zjawisko jest znane wszystkim, niestety, a może i stety, ze względu na to, że ten ból ma dwie twarze. Jedna twarz to jest ta, która pozwala nam przeżyć, pozwala nam uniknąć uszkodzeń, chorób, jest takim wczesnym alarmem, że coś się dzieje niedobrego. I to jest ta akceptowalna rola. Natomiast jest ten drugi, dramatyczny obraz bólu, który spędza badaczom, poszukiwaczom nowego leku sens powiek. To jest bardzo poważny problem, który od lat męczy ludzi, szczególnie wtedy, kiedy przechodzi formę przewlekłą. Z bólem ostrym jesteśmy w stanie sobie już radzić, natomiast ból przewlekły, zwany chorobą samą w sobie, jest bardzo trudny do leczenia. Ja przedstawię dzisiaj badania dotyczące bólu neuropatycznego. To jest jeden z rodzajów bólu przewlekłego, bardzo trudny w leczeniu z wielu względów. Jednym z tych powodów jest to, że rozwija się po uszkodzeniu układu nerwowego, ale przyczyny tych uszkodzeń są bardzo różne. To może być mechaniczne uszkodzenie, na przykład w czasie operacji. U kobiet po mastektomii w 5% rozwija się ból neuropatyczny. Ale też przyczyną mogą być zmiany metaboliczne, mogą być toksyny, może być nowotwór, który rozwija się i uszkadza układ nerwowy. A więc mając do dyspozycji taką gamę przyczyn, trudno jest znaleźć jeden lek, który będzie pomagał w złagodzeniu tego cierpienia. Ten ból neuropatyczny jest w tej chwili wykrywany około 10% globalnej populacji, ale już w wieku powyżej 75 roku życia to osiąga prawie 50% populacji. To bardzo wysoki procent, dodając jeszcze to, niestety, że zwiększa się ta liczba chorych z bólem neuropatycznym, rośnie. Z wielu względów, również z pozytywnych, przedłuża się okres życia człowieka, ale też udaje się przetrzymać długo chorych, którzy cierpią na choroby, które mają dużą szansę rozwinąć później, po których u pacjenta może się rozwijać ból neuropatyczny, tak jak właśnie na przykład choroby nowotworowe. I trzeba sobie zdać z tego sprawę, że cierpienie ludzi na ból neuropatyczny, ci, którzy chorują na ból neuropatyczny, mają dramatycznie obniżoną jakość życia. To jest, dochodzi do tego, że zmieniają pracę, że muszą zmieniać styl życia. To jest bardzo poważne zakłócenie jakości ich życia. A poza tym pociągają za sobą, pociąga ta choroba jeszcze oczywiście koszty leczenia i koszty zwolnienia pracowników, czyli jest to choroba bardzo kosztowna. Ja starałam się uzasadnić Państwu podjęcie tego tematu. Czym się charakteryzuje ból neuropatyczny? Dwa objawy są objawami osiowymi, które również wykorzystujemy w badaniach przedklinicznych. To jest alodynia, rozwijająca się alodynia, czyli wrażliwość na bodziec, który w kontroli czy w fizjologii nie powoduje żadnej reakcji. To nie jest bodziec bólowy, to jest zupełnie nieszkodliwy bodziec, taki jak dotknięcie skóry czy przesunięcie się tkaniny po skórze. I hiperalgezja, która oznacza obniżenie progu bólowego na bodźce bólowe. Te dwa objawy bardzo dobrze też charakteryzują modele zwierzęce. I w naszych badaniach korzystamy właśnie też z tych badań. To, co było powodem naszego zainteresowania się bólem neuropatycznym i poszukiwania leku, to był fakt, że ten ból jest oporny na leki opioidowe. Wydaje się nam, że to wielka szkoda, że nie możemy użyć opioidów w leczeniu bólu przewlekłego. Oczywiście zdaję sobie sprawę z efektów niepożądanych, ale gdyby dało się wykorzystać opioidy w bólu, co do którego mamy wielkie problemy z terapią, byłoby znacznie lepiej. To, że że ten ból jest oporny na leki opioidowe, jest takim naszym triggerem, naszym początkiem zainteresowania. Jeżeli popatrzymy, jak wygląda efektywność morfiny w bólu neuropatycznym w eksperymencie, to jest kontrola i ból neuropatyczny w eksperymencie, w modelu bólu neuropatycznego. Proszę zobaczyć, przesunięcie efektywności morfiny jest powyżej 1 rzędu dawki. W eksperymencie 5 mg na kilogram daje nam bardzo silną analgezję morfiny. Natomiast żeby w modelu bólu neuropatycznego podać morfinę i uzyskać ten sam efekt, używamy 20 mg na kilogram, więc widać, że jest ogromna różnica. Oczywiście było wiele badań, w których badacze starali się wytłumaczyć, skąd się bierze to ciekawe zjawisko, takie obniżenia efektywności morfiny w tym bólu. Niemniej jednak żadna z tych dróg nie doprowadziła do jakiejś takiej widocznej poprawy, jeżeli chodzi o terapię bólu neuropatycznego. Ponieważ jesteśmy na spotkaniu, które jest spotkaniem jubileuszowym, wydaje mi się uzasadnione wrócić trochę również do dawnych lat 70. ubiegłego stulecia, kiedy to odkryto endogenne peptydy opioidowe. A dlatego o tym mówię, że my zaczęliśmy poszukiwać przyczyny tej niewrażliwości właśnie w endogennych układach opioidowych. Jeżeli morfina ma obniżoną efektywność, to znaczy, że coś się dzieje w układzie receptorów opioidowych, czyli endogennych układów opioidowych. I od tych lat 70., kiedy odkryto zarówno peptydy opioidowe, jak i ich receptory, jeszcze z sentymentu pokazuję bardzo stary plakat, który właśnie pod koniec lat 70. moi współpracownicy się uśmiechają, bo faktycznie ja ten plakat bardzo lubię. Wtedy już w taki zabawny sposób usystematyzowano endogenne systemy opioidowe. To jest system proopiomelanokortyny, system proenkefaliny i system prodynorfiny. Te prohormony, z tych prohormonów powstają peptydy opioidowe działające na 3 receptory opioidowe mi, delta i kappa. Jak widać, one nie są bardzo selektywne, są mi delta, jest delta mi. W każdym razie ten stan wiedzy, który osiągnęliśmy wtedy, został pogłębiony. Mamy znacznie więcej już pewnych dowodów, że tak te systemy wyglądają. Tam są niewielkie różnice jeszcze, jeżeli chodzi o nocyceptynę czy endomorfinę, ale to jest ten główny pion. Na tym zaczęliśmy naszą pracę, oparliśmy naszą pracę. Wiadomo, że są 3 prohormony układów opioidowych endogennych, POMSI, proopiomelanokortyna, proenkefalina i prodynorfina. Z tych łańcuchów drogą cięcia enzymatycznego powstają dłuższe i następnie krótsze peptydy. Ale to, co jest interesujące i na co chciałam Państwu zwrócić uwagę już tylko na przykładzie proopiomelanokortyny, to powstają oczywiście peptydy dłuższe, a potem krótsze. Ale wśród tych peptydów proszę zauważyć peptydy opioidowe, jak beta-endorfina, silny analgetyczny peptyd opioidowy, ale powstają peptydy nieopioidowe, które mają przeciwny profil. I tak w każdym z systemów opioidowych endogennych istnieje coś takiego jak funkcjonalny antagonizm. Powstają peptydy opioidowe, jeszcze raz to pokażę, beta-endorfina, która jest silnym analgetykiem, i powstają melanokortyny. Z proopiomelanokortyny powstają melanokortyny, które wywołują hiperalgezję, są silnie probólowe. To był punkt wyjścia naszych badań i jeszcze raz pokazuję ten prohormon, receptory i funkcja. Proszę zobaczyć, beta-endorfina, która jest peptydem opioidowym, działa przez receptor mi-delta, wywołując analgezję silną, to jest jeden z silniejszych analgetyków, i cały szereg melanokortyn, alfa-gamma-melanokortyna, działająca na 5 receptorów melanokortynowych. Te receptory, to troszkę za szybko przeskoczyło. Te receptory to jest bardzo ciekawa grupa receptorów nieopioidowych, ale jeden z nich, a szczególnie receptor MC4, jest związany z bólem. Aktywacja tego receptora powoduje bardzo silny ból. Natomiast pozostałe mają też szereg innych działań bardzo ciekawych. Receptor MC3, MC4 są związane z pobieraniem pokarmu, wykorzystywane też w zakresie poszukiwania leków przeciw otyłości, ale to jest inny problem. My skupiamy się na tych 2 elementach, które powstają z tego samego prohormonu, a więc na opioidowym i nieopioidowym peptydzie i tym receptorze MC4 i receptorach opioidowych. Ponadto receptor MC4, który jest właśnie silnie, aktywacja prowadzi do silnej bólowej reakcji, jest zlokalizowany w drogach nocyceptywnych, również w strukturach mózgu, we wzgórzu. Też jest ekspresja jest bardzo wysoka. Więc ten receptor znalazł się w zakresie naszych zainteresowań i postawiliśmy taką hipotezę. Jeżeli uszkodzenie neuronu, jakiegoś nerwu, czy uszkodzenie układu nerwowego, powiedzmy ogólnie, bo również mogą to być struktury ośrodkowego układu nerwowego, jeżeli dochodzi do tego, wzrasta ekspresja propiomelanokortyny, bo o tym wiemy i takie dowody są, i powstaje cały szereg peptydów. Powstają peptydy opioidowe, ale również peptydy nieopioidowe, silnie probólowe. Czy możemy spróbować odwrócić to osłabione działanie morfiny, modulując aktywność czy blokując aktywność układu melanokortynowego? To było pytanie, które zadaliśmy. I w szeregu eksperymentów, siłą faktu skracając 20 lat badań, muszę Państwu wyselekcjonować na 20 minut pojedyncze przeźrocza, żeby pokazać, jak to wygląda. To są oczywiście olbrzymie skróty, ale proszę zobaczyć, podanie substancji melanoton 2, który jest agonistą receptora MC4, powoduje bardzo silną alodynię w modelu zwierzęcym. I przeciwnie, jeżeli podamy antagonistę tego receptora, uzyskujemy bardzo silną analgezję. Antagoniści, tutaj stosowaliśmy zarówno SHU, jak i OTKC, selektywni antagoniści tego receptora MC4, uzyskujemy analgezję. Silną analgezję. Co więcej, to nasze pytanie było, czy nam się uda odwrócić to osłabione działanie morfiny i faktycznie, jeżeli podamy morfinę, to jest ta dolna linia, wyższa to jest SHU, ale przed morfiną podamy SHU, to się bardzo nasila działanie morfiny. Czyli uzyskujemy znacznie silniejszy efekt analgetyczny, blokując ten probólowy efekt układu melanokortynowego. To były pojedyncze podania, ale to nas zachęciło do poszukiwania w dalszym ciągu i jak się okazuje, to jest znany fakt, oczywiście jak się podaje morfinę, to rozwija się w eksperymencie 6 do 8 dni tolerancja, to jest ta linia dolna. Natomiast jeżeli przed każdym następnym podaniem morfiny zablokujemy receptor MC4, to tolerancja się nie dość, że nie rozwija w pierwszych dniach w ogóle, ale jest znacznie opóźniona, przedłużona. To również jest pokazane na polu pod krzywą na dolnej rycinie. Ale ten wynik, który już naprawdę nas przekonał, że mamy w ręce wielkie możliwości, to był wynik doświadczenia, w którym wytworzyliśmy już tolerancję na morfinę. To było wiele podań morfiny. Okazuje się już to podanie, które tutaj jest na czarno zaznaczone, nie wywołuje żadnej reakcji analgetycznej. Natomiast jeżeli podamy ją jeszcze raz, ale wcześniej zablokujemy receptor MC4, uzyskamy niezwykle silne działanie, czyli odwracanie tolerancji pojedynczym podaniem. Czyli mamy w ręce narzędzie, które jest niesłychanie silne i możemy spróbować użyć go, żeby to, co wytwarza się w bólu neuropatycznym, ta niewrażliwość morfinowa, żeby ją jakoś przywrócić, żeby można było w sytuacjach trudnych pacjentów jednak jakoś leczyć. To jest takie zebrane powtórzenie tego, co uzyskaliśmy po pojedynczym i po wielokrotnym podaniu antagonistów MC4. Natomiast dodatkowo, bo można się zastanawiać, jeżeli powstaje równocześnie dużo peptydów przeciwbólowych i probólowych, to co się dzieje, że najpierw jest efekt analgetyczny, a po pewnym czasie zaczyna przeważać system probólowy? To się dzieje w ten sposób, że okazało się, że wiemy z doświadczenia, że receptory opioidowe przy dużej podaży peptydów opioidowych, które są uwalniane endogennych, mają takie sprzężenie zwrotne. Zaczyna słabnąć synteza receptorów opioidowych. Natomiast przeciwnie dzieje się z receptorem MC4. Receptor MC4 przy rozwoju bólu neuropatycznego, to jest kontrola i 2 późniejsze czasy, po stronie uszkodzenia, czyli jest związany z tym uszkodzeniem, wzrasta jego ekspresja. również na tym, to są przeźrocza ze starych naszych badań, co widać, i również ekspresja RNA i białka rośnie. Czyli nie jest powiedziane, że wiadomo, że ten proces aktywacji receptora, następnie jego internalizacji, przejścia z powrotem, ten obrót receptora jest jednakowy w dwóch systemach. Naszym zdaniem on się zmienia. Początkowo po uszkodzeniu dochodzi do aktywacji receptorów, aktywacji prohormonów, ekspresji prohormonów opioidowych, powstają peptydy, powstają i te, i opioidowe, i nieopioidowe, ale ten tor opioidowy szybciej się wyczerpuje, natomiast do głosu dochodzi tor probólowy, receptor MC4. Czyli można powiedzieć w ten sposób, że ta sytuacja w bólu neuropatycznym bierze się z zaburzonej równowagi pomiędzy tymi dwoma systemami, które w fizjologii funkcjonują obok siebie i stanowią takie dwie drogi reakcji i dwie możliwości. Stąd powstała idea związku, który syntetyzujemy i będzie to związek, który będzie składał się z dwóch farmakofor, z dwóch części. W jednej części będzie to agonista receptora opioidowego, a z drugiej antagonista receptora melanokortynowego. I to wzmocnimy działanie to analgetyczne i przyhamujemy działanie probólowe. To, co jest ważne, dlaczego nam chodziło o to, żeby to był jeden związek, żeby to było w tym samym miejscu. I taka sytuacja, taki związek może nam przywrócić tą równowagę, którą wykorzystamy w terapii w jakikolwiek już sposób. Nawiązaliśmy kontakt z chemikami, peptydowcami z Warszawy, z grupą pani profesor Misickiej-Kęsik na Wydziale Chemii Uniwersytetu Warszawskiego. To świetna grupa, która właśnie zajmuje się tego typu problemami i profesor Misicka zgodziła się na współpracę z nami. Napisałyśmy grant maestro, w którym właśnie zaplanowałyśmy syntezę takich związków hybrydowych i badania tych związków. Ola ze swoim zespołem syntetyzowała 10 hybryd, które właśnie miały te dwa farmakofory połączone łącznikiem. Ten łącznik jest bardzo ważnym elementem tej naszej hybrydy. I to jest analog enkefaliny bardzo silnie działający i antagonista melanokortynowy. Rozpoczęliśmy badania. Proszę Państwa, to jest parę lat pracy. Nie jestem w stanie pokazać ani tych tabel zestawień, ani tego, co otrzymaliśmy w tych badaniach. Pokażę tylko, że te hybrydy działają bardzo silnie w podaniach. To jest podanie dożylne, podanie podpajęczynówkowe i podanie dooczewnowe. Więc jest to bardzo dobra możliwość, żeby uzyskać jakiś efekt. Ale to, co zawarłam w tym przeźroczu, jest właściwie takim podsumowaniem tego, co otrzymaliśmy. Z tych 10 hybryd 3 okazały się bardzo silne, działające wyjątkowo. A to, co jest bardzo ciekawe w tym, jeżeli popatrzymy na efekt tych dwóch hybryd, bo tu są przedstawione dwie, to w grupie kontrolnej ich działanie jest słabe, niezbyt interesujące. Natomiast jeżeli podamy w modelu bólu neuropatycznego, to dochodzi do bardzo silnego działania. To nas utwierdziło w przekonaniu, że znaleźliśmy ten istotny punkt, bo jeżeli udało się nam wytworzyć taką substancję, która reaguje na sytuację patologiczną, czyli w tym modelu bólu neuropatycznego doszło do tej przewagi aktywności układu probólowego, endogennego i my podając jeszcze tą naszą hybrydę, wzmacniamy działanie opioidowe, hamujemy działanie probólowe i uzyskujemy w tym modelu wyjątkowo silne działanie w porównaniu z działaniem kontrolnym. To nie jest związek, który będzie działał w bólu ostrym i w bólu przewlekłym. To jest hybryda, która jest celowana wyraźnie na ten mechanizm, który badamy. Ale oczywiście recenzenci publikacji zapytali, no co za różnica, dlaczego nie podacie tych dwóch substancji osobno, tylko ze sobą zmieszanych. Po co robić hybrydę? No i to przeźrocze pokazuje Państwu różnicę zasadniczą. Otóż to jest pierwszy słupek, to jest morfina SHU i potem są ze sobą zmieszane. Znaczy nie morfina, bo to jest właśnie ta enkefalina. To są dosłownie składniki, które tworzą hybrydę, zmieszane fizycznie, tylko przy zachowaniu oczywiście dawki i podane razem w jednym czasie, w jednym roztworze. I to są wyniki z podania hybrydy. No widać, że to jest zupełnie inna jakość. To nie tylko, że jest wielokrotnie silniejsze działanie, ale też, czego już też nie pokażę, to jest działanie znacznie dłuższe. Te hybrydy działają znacznie dłużej niż związki macierzyste kolejno. Więc stworzyliśmy nową wartość, która ma wartość dodaną, to znaczy pojawia się coś więcej niż tylko ta wzmocnienie działania. To, co by było, gdybyśmy podali tylko je osobno, czy podali wcześniej MC4. To już jest taki wynik, który spowodował, że mając w ręce te cechy, te hybrydy 3, które działały tak wyraźnie, to jest suma, to jest jeszcze raz powtórzone cechy tej naszej hybrydy i zrobiliśmy oczywiście zgłoszenie patentowe, bo w takiej sytuacji chcieliśmy jakoś to wzmocnić, te nasze badania i te nasze wyniki i udało się nam. Mamy w tej chwili już patent Stanów Zjednoczonych na strukturę tych substancji. To jest nie tylko te dwa farmakofory, ale również charakterystyka łącznika, który jest bardzo tutaj istotnym elementem w tym połączeniu dwóch substancji. Więc mamy patent na strukturę tych 3 hybryd i dodatkowo nie tylko na strukturę, ale na ich działanie w bólu neuropatycznym. Wydaje się nam, że to jest już takie osiągnięcie, które możemy Państwu przedstawić i teraz co dalej, to się okaże. W każdym razie na tym tą część naszego poszukiwania i naszej drogi do tego leku, który jeszcze oczywiście nie jest lekiem, chciałam Państwu przedstawić. Natomiast chciałam podziękować zespołowi chemików z Uniwersytetu Warszawskiego, to jest pani profesor Misicka, Ewa Witkowska i Beata Wileńska, no i moim współpracownikom, obecnej zresztą na sali pani profesor Katarzynie Starowicz-Bubak, Joannie Starnowskiej-Sokół i Ani Piotrowskiej-Murzyn. Dziękuję Państwu bardzo za uwagę.
Dziękuję serdecznie. To naprawdę fascynujące, taka celowana terapia wedle mechanizmu, prawda?
Tak, to jest właśnie dla nas takim największym źródłem nadziei, że coś się da, że to jest dokładnie skierowane na mechanizm bólu neuropatycznego. Trzeba mieć świadomość, że ból neuropatyczny jest leczony lekami przeciwdepresyjnymi. Jest bardzo dużo leków, ale one nie są tak związane z mechanizmem.
No, nie działają przyczynowo.
Tak, więc, a tutaj udało się nam coś takiego, co wydaje mi się istotne. Co się okaże, niestety bardzo wiele badań takich obiecujących na zwierzętach nie przechodzi próby badań klinicznych, no ale od czegoś trzeba zacząć.
Trzeba próbować. Zapraszam do zadawania pytań. Przepraszam. Tak.
Dziękuję bardzo. Jako laik, ale człowiek, którego coś tam czasem boli, jak wszystkich, chciałbym dwie sprawy tutaj poruszyć, zapytać, a mianowicie, czy skłonność do odczuwania bólu, wrażliwość, podatność na ból się dziedziczy, czy każdy ma swój własny ból? Czy w ogóle są jakieś badania na ten temat? To jedna kwestia. I druga, co pani sądzi o tej całej wielkiej sferze medycyny tak zwanej niekonwencjonalnej, ci różni szamani, bioenergoterapeuci, którzy, hipnotyzerzy, którzy mają udowodnione przypadki uśmierzenia bólu, jakiegoś oszołomienia, czy rzeczywiście oni mogą mieć wpływ na odczuwanie subiektywne bólu przez tych chorych?
Zacznę od tego drugiego pytania. Oczywiście mogą mieć wpływ, dlatego że my w bardzo duży sposób, każdy pacjent odczuwa ten ból subiektywnie. To jest nawet trudne w ocenie lekarzy. Ja nie jestem lekarzem, w związku z czym nie chcę się wypowiadać bardzo autorytatywnie. Natomiast lekarze mają kłopot w określeniu, na przykład zrobieniu badań klinicznych, żeby określić, czy pacjent mówi prawdę, czy nie o bólu, prawda? To nie jest łatwy problem. A na pewno nasz stan ducha, nasza wiara w to, co się stanie, nasze oczekiwania, jaki będzie wynik leczenia, nasza wola wyzdrowienia, to wszystko bardzo silnie wpływa. To już jest kwestia psychologii bólu, zresztą również bardzo ciekawa tematyka, ale jak gdyby odpowiadam na to pytanie, tak, może to mieć wpływ, ale bardzo często prowadzi do znacznie pogorszenia tego, dlatego że my nie jesteśmy w stanie absolutnie zapanować nad bólem tylko naszym myśleniem o tym czy oczekiwaniem. W związku z czym bardzo trzeba rozważyć, jeżeli ktoś próbuje takich metod, czy to jest opłacalne, czy warto zaprzepaścić szansę wyleczenia, jeżeli tylko taka jest, bo można przeciągnąć na tyle, że to się nie uda potem już. Natomiast pierwsze pytanie. Dziedziczymy na przykład właśnie odczuwanie bólu razem na przykład z kolorem włosów. Ja nie mówiłam o tym, ale jak pokazywałam Państwu ten slajd, w którym jest szereg receptorów melanokortynowych. Receptor melanokortynowy 1 też jest w tej chwili naszym punktem zainteresowania, dlatego że on się wiąże z ubarwieniem sierści, skóry, koloru włosów u ludzi i ten rudy kolor włosów, który powoduje większą wrażliwość na ból u ludzi, jest też związany z receptorem melanokortynowym 1. On też jest związany z bólem nie tak silnie jak MC4, ale też. Więc jest to też dziedziczna wrażliwość.
Jeszcze mamy jedno pytanie, proszę.
Chciałem zapytać o ten linker. To bardzo fascynująca historia, gratuluję. Dwa pytania króciutkie, właściwie jedno. O hydrolizowalność tej hybrydy, bo ona, rozumiem, może być rozkładana in vivo, więc takie peptydy nie będą bardzo trwałe i trzeba je podawać dożylnie. A drugie pytanie o ten linker. Czy rozumiem, że ten synergizm można osiągnąć przez jakąś odpowiednią
Bardzo
długość?
źle Pana słyszę.
Długość linkera, a efekt synergistyczny i hydrolizowalność związków. Dwa krótkie pytania.
Tak, jeżeli chodzi o długość linkera, myśmy z tych 10 hybryd, okazało się, wybrane zostały te 3 do patentu, które mają linker giętki, bo były linkery sztywne, giętkie, dłuższe i krótsze i ten giętki okazał się być lepszy, z tym, że od razu wyjaśniam, my nie zakładamy, chociaż takie badania też w trakcie prowadziliśmy, to znaczy podejmowaliśmy próbę z badania, czy wytwarzają się w bólu neuropatycznym dimery receptora MC4 i opioidowego. I czy ta nasza hybryda nie jest taką hybrydą, która siada na tych dimerach, a one mają bardzo ważne działanie istotne w bólu. Niestety nie udało nam się tych badań kontynuować, ale raczej uważamy inaczej, że ponieważ to jest jedna substancja, ona podawana, ona się znajdzie zawsze w tym samym miejscu. Nie tak jak dwie osobno, które mają swoją farmakodynamikę i będą w różnym tempie przechodzić do różnych kompartmentów tkankowych, tylko to jest, ten związek zawsze będzie w jednym miejscu i w tym samym miejscu będzie powodował te swoje dwa działania, co daje szansę nasilenia. Więc to jeżeli chodzi o dimery, nie prowadziliśmy, nie jestem w stanie powiedzieć nic na temat hydrolyzowania tego. Nie mam takich badań czy takiej wiedzy.
Dziękujemy bardzo jeszcze raz. Oczywiście peptydomimetyki by były lepsze, ale to Big Pharma się tym zajmie, bo to trzeba miliardy na to.
Ale my w tej chwili napisałyśmy z Olą grant, który do NCBR-u w Szybkiej Ścieżce. Dostałyśmy fundusze na zbadanie właśnie wszystkich możliwości zastosowania tego leku w klinice, w badaniach klinicznych.
Jeszcze raz dziękuję pani profesor za bardzo interesujący wykład i proszę państwa, zostaniemy już w dziedzinach bardziej medycyny społecznej, mianowicie mam przyjemność.
All right, so now it's time for Professor Andrzej Pająk from the Department of Epidemiology and Population Studies at the Institute of Public Health of Collegium Medicum Medical College of Jagiellonian University, and he's been studying condition of health of Poles, so definitely he may have some recommendations connected with our lifestyle, and he's going to talk about cardiovascular diseases in this context. Thank you. Let me say thank you for organizational committee of the Polish Academy of Arts and Sciences, because they gave me a great pleasure and honor to deliver this presentation to you. As a doctor, medical doctor by education, I have to say I reflect, or let me rephrase it. You've been listening to previous presentations, so I want to say that whenever I think about the progress that has been made in contemporary medicine, even in my professional life, I always think about that with huge enthusiasm. On the other hand, I present a certain duality in thinking about that, because apart from enthusiasm, I'm thinking whether I would like to experience all the benefits of all these methods that have been discussed so far. Well, I guess I wouldn't. I would prefer to avoid such a necessity, and if they were necessary, if I were in such a poor health condition that I might use them, I would like to postpone this necessity till as late as possible, and I'm going to focus on that in my presentation. Before I move on to the main message, I'd like to present our project briefly. It has a very nice name because it is called HAPPY. It is this time an abbreviation from the title, which is Health, Alcohol and Psychosocial Factors in Eastern Europe, or Risk Factors in Eastern Europe. It is the project which has been conducted in 4 countries of Eastern Europe. So it was Poland, the Czech Republic, Lithuania, and Russia. And in the years 2002, 2005, we examined about 30,000 people in Poland. And the Polish part of the study was about Kraków population. So we examined more than 10,000 men and women, 45 up to 69 years of age. And these people were observed from the perspective of death rate and morbidity of circulatory diseases, and they were observed for 10 years. We've been still observing these patients till today. So I wanted to introduce this project because the majority of the data that will be discussed in my presentation are derived from this particular project. Not all of them, but I will mention that whenever it is not the case. So I am sure that the majority of you know what are risk factors for cardiovascular diseases. So cardiovascular diseases mean the diseases which are based on that. So basically, these are features which increase the likelihood of falling ill with cardiovascular diseases, and they are based mostly on arteriosclerosis. And here you can see all the risk factors: hypercholesterolemia, hypertension, smoking, obesity, diabetes, low physical activity, atherogenic diet, high consumption of alcohol, ethanol. The red ones are connected with the lifestyle. The black ones are quite relative. So the red ones are connected with the lifestyle. Obviously, I don't have time to discuss each risk factor at length, because each one of them has at least one scientific society, international scientific society, and there are like several scientific conferences around each factor every single year. So I'm not going to do that, but I will refer to several problems that I consider to be of great importance. So the most important results, or my point is that at the end of this road is death. So due to these risk factors, you may be endangered with death. If I think about our morning session today, I can ask whether physical activity should be performed in Kraków. It is the city which is notorious for its air pollution. And then causes of causes. I know there is a mysterious phrase, but I'm going to explain it later. And at the end of my presentation, I will try and say what should be done about that. Let me begin by saying a few words about smoking. It was among the first analyses that we carried out because, well, smoking kills. People knew that when we started to design our project. So this information is placed on every packet of cigarettes. I just wanted to highlight two numbers. It is the number of deaths annually which are related with smoking. So these deaths can be attributed to people's active contact with smoking. They were either active smokers or passive smokers. So in Kraków, 2 up to 3 people a day aged below 70 years of age die because of smoking cigarettes. So it sheds bad light on people who are trying to be relative about that, or are trying to undermine the information about how detrimental smoking is, but they are also going against the European law, because there is a document adopted by the European Parliament which says that every person in Europe has the right to live without a cardiovascular diseases till the age of 70 years of age. So in a nutshell, if someone dies before that age, it is a premature death. About 1,000 deaths like that happen in Kraków annually. So it is definitely against the EU law. And then ethanol. Well, alcohol consumption. So the situation is more complex here. Poland, against a certain reputation that we have is not the nation, not the country with the highest alcohol consumption. So that's pure alcohol consumption in European countries, and Poland, as the only representative of the countries which participate in our project, was clearly below the average for Europe.
Natomiast jeżeli chodzi o zależność,
As for dependence between alcohol consumption and death risk, it is presented here. Well, because such graphs will be more numerous, I will show like a few of them, so perhaps I should explain what is shown here. On the vertical axis, there is an index which indicates how many times the risk of death is greater in the subgroups of tested people defined according to information given below about the amounts. So these are subgroups which consume a certain amount of alcohol, clearly specified at the bottom. This index is shown by means of this black shape. It shows that the risk is higher than in the referential group. So it is like this black rhombus. And the point of reference is people who drink alcohol, but less than 10 grams of pure alcohol per day. And it is a group of people who drink alcohol, but very little alcohol. And the risk level is manifested in this straight black line. So it is like our reference line. Here, we could see that if we look at deaths related to alcohol, there is a correlation of the risk. People drinking more than 60 grams a day, especially men, have twice higher risk of death than the others. As for cardiovascular diseases, we have a U-curve. The lowest risk appears for people who consume moderate amounts of alcohol, people who drink a lot of alcohol have an average estimate of risk at quite a high level, but in our study we have a quite big range of uncertainty of the result, and it is shown here by this vertical thin line. What may be quite worrying is information that it is also bad if people don't drink alcohol at all. We have higher risk there, and vertical lines are quite thin, which means that our study was quite precise here. But I would notice that deaths related to alcohol, dependent on alcohol, are more highly likely. So it means that this group is, well, infected with people who have had poor health since the beginning. We are trying to we were trying to take into account this particular factor, so poor health initially, but it was very difficult. So, for example, we may have former alcohol addicts, so their health had already been damaged. And even though they do not drink any alcohol now, still they are in poor health. And I would say this part of the graph shows it very clearly. So that's the situation for men, for women, quite similar. And in intense alcohol drinking, the risk for women is slightly higher than diet. These are dietary recommendations which are promoted nowadays by Cardiological Society, and there are 11 international societies which promote these dietary recommendations. Well, there hasn't been any change on this list for many years, but if you have a closer look at that, and if you read all the details, these are recommendations which are great for dietitians, those who prepare our diet. But if we want to apply it in practice, well, we would have many problems. We don't eat either ingredients, we don't eat health products, no, we eat meals. We eat meals, or we eat according to a certain dietary pattern. It was noticed by experts in these international organizations, and they suggest certain patterns or solutions that have been tested, and they were proved beneficial for human health. And one of them is Mediterranean diet, which is, it is a very strong recommendation that if you eat according to the Mediterranean diet, you will decrease your risk of cardiovascular diseases by 10%. It is quite a lot. It is quite a lot. But the Mediterranean diet in the Kraków population is followed by, let's say, 30%, not much. I was quite surprised to find that the belief that in our climatic conditions, which are illustrated by this painting by Stanisław Wyspiański. I absolutely love this painting because it shows the area in which I live at the moment. So in our climate, it turns out that many people believe that a typical traditional East European diet based on animal fat will be better. So I was quite surprised to find during one of scientific sessions in which I participated about various dietary patterns, towards the end, there was like voting which diet will be the best for Poland. So, surprise, surprise, the majority of people who are basically experts said that the Polish diet or the traditional diet will be the best. Hands down, this opinion won. So we didn't have correct information or full information. Well, people may believe that, why not? But in our study, we proved that typically Eastern European diet in Kraków is followed by, again, more or less 30% of people. Unfortunately, for these people, we have to say that this index, or high index, if you compare this traditional Polish diet with other diets, the risk of death connected with cardiovascular diseases is much higher if someone follows and applies the Polish diet. So this diet is also not favorable if you look at deaths of cancer, which is then translated into statistically significant results for deaths in total. We have confirmed a beneficial influence on health condition and death rates of Mediterranean diet. So I think it is worth considering. Physical activity. It is a ratio between the time of physical activity and the risk of death for all the causes actually here. It is a graph on the basis of a large study in the US of people who are middle-aged. Almost 90,000 people were taken into account. The biggest benefit is for those who have not zero physical activity, but like moderate, or like between 10 minutes and 1 hour per week. That's the biggest benefit. The risk of death goes down by 18%. Then there is growing time of physical activity up to the one recommended between 150 minutes and 300 minutes a week is connected with additional benefits, namely further 10%, up to 30% of decreasing the risk of death. In a city like Kraków, I have come across an opinion like that. You talk about physical activity so much, you encourage people to do sports, but sports are happening outdoors most of the time, and it is connected with the fact of inhaling polluted air that we have in Kraków. There were some smog alarms, so if you breathe in the air in Kraków during physical activity, you are poisoned actually. Well, so there are contradictory health effects. There are two powerful determinants of health. On the one hand, we have physical activity, which has a beneficial impact, and on the other hand, unfavorable impact of air pollution and natural environment pollution in Kraków. So these relations are quite well described in terms of quantity. There are interesting estimates carried out by Pinsky, and I guess he did it in Oxford, in England, and he tried to estimate this dependence between the time of doing some physical exercise and the risk of death for all the causes for various levels of being exposed to pollution in the environment. So this graph shows that this dependence between time of activity and the risk of death for PM 2.5 pollution. It is this fine particle pollution which goes through the barrier lung blood and permeates blood and tissue. So for this level, 50 micrograms per cubic meter, it is slightly above what we have come across in Kraków at the time when we didn't have a ban on using coal furnaces, coal-fired furnaces. According to these estimates, if you compare it with people who are not physically active and start their physical activity, the benefit resulting from physical activity is going up if the time is longer. And we reach a tipping point. It is the point of the biggest benefit here. For this concentration of dust, slightly more than 1 hour. But then this benefit is beginning to go down. And at a certain period of time, like 5 hours, like cycling, there is a break-even point. So it's breaking even between benefits and damages. Benefits from physical activity and damages and harm connected with your exposure to dust and polluted air. And if the time is longer, the situation is getting worse and worse. The Finnish scientist estimated these times for European cities in which average pollution amounts to 37 micrograms per cubic meter. And it is what we have at the moment in Kraków. It turns out that the tipping point, so the time of the biggest benefit, is obtained if we cycle for 2.5 hours per day, cycle 2.5 hours per day. It is not very intensive, so like cycling, but for quite long, 2.5. The break-even point will be much longer. It will be 9 hours, as much as 9 hours of cycling. For cities with the biggest air pollution, 90 micrograms per cubic meter, these times are obviously shorter. Practically speaking, for the activity like walking, there are no limits. So, on the basis of these studies, we can see that physical activity is still recommended, and there will be no detriment to health connected with environmental pollution. This analysis is enriched. Simply, there was additional contribution several years later, namely what would happen if we gave up on physical activity, if there is the biggest concentration of pollution in the air. And cities like Polish cities, where these days of extreme values of pollution, well, it will not have any negative impact, obviously, unless you just limit your physical activity on the days with intense smog. That's it. Causes of causes. What do I mean by that? I'm using the word we very often, perhaps excessively so, but my point is that our awareness, our scope of knowledge is great. We know quite a lot about diseases, health, causes of death. We know quite a lot about that. We have a vast body of knowledge about that. Our pathophysiological knowledge, so damage to organs which lead to death, which lead to severe conditions. Yes, also a lot of knowledge there. There are risk factors like hypercholesterolemia, hypertension. Now we know that these conditions depend on our behavior, health behavior. Health behavior does not appear in a vacuum. They are shaped by the social environment, by the working environment, by the culture. And these are causes of causes. And additionally, they are determined by a social system, a political system. So we have to look for ways of improving the situation. I'm not talking about like, I don't know, some self-help books that you should do this or you should do that. No, we should think about determinants of health. So social structure, working environment, social environment. So in our study, these dependencies were very much visible. A sense of control or perceived control. It means to what extent we believe that we control our health situation, our living situation. It is quite well measurable. You can use various questionnaires, various methods, and you may notice that it has a big impact on survival rate. These are Kaplan-Meier curves showing the percentage of people or likelihood of surviving depending on the time that passes. And you can see that the red lines, so these are people with low sense of control. They are at the lowest, so these people die faster. And we can say the same, but less clearly, about cardiovascular diseases. People who have lower sense of control over their health situation die faster. So the psychosocial background of diseases is manifested very clearly. I would say in Kraków it was most visible from among these countries which participated in the project. So what should be done here? We have two strategies of influencing their lifestyle, of influencing risk factors. The first one is more connected with medicine, like finding the threatened people and including them into healthcare. But medicine as such and the healthcare system has a problem with this active identification of threatened individuals or including all of them into the healthcare system. Well, so we can't really do that. And the other strategy is for the whole population, or population strategy, or population approach. It is about exerting a positive influence on determinants of health of the whole population. So it is exerting influence on everyone, the sick, the healthy, and the ones with low and high risk factors. It is a set of recommendations for population strategy or population approach to physical activity. You can see there is a long list of recommendations, and this list of recommendations is prepared for all risk factors I'm discussing. I'm not going to discuss it in detail. I just wanted to highlight the information, like who the addressee is, who is the recipient of these recommendations. It is not for doctors. It is neither for doctors nor for patients. So these are recommendations for the government, for authorities, local authorities, for those who are responsible for education, educators, health educators, those who inform us through labels on food, to institutions which come up with economic incentives to shape a better lifestyle, to schools, working places, local communities. It is not a joking matter. It turns out that there are estimates that if we introduced all these recommendations in practice, death rates connected with cardiovascular diseases could go down by 50%. So that's the potential that we have if we applied all prevention measures. The epidemics of circulatory diseases could be brought down by 80%. Obviously, we could think about the capabilities of modern medicine, and modern medicine would be able to handle the remaining 20%. So the potential of prevention is great. There is a great potential of this population approach. I was trying to be very brief. If I was talking for too long, I want to say, well, I apologize for that, but I had a certain message, and I didn't want to skip too much of the main message. If you are interested in more details of this subject matter, every year in Kraków we have Preventive Cardiology Conference, and it is the place where we discuss this subject matter in detail. Thank you very much for your attention.
Dziękuję bardzo, panie profesorze.
Thank you, Professor. Yes, we are delayed. We do apologize for that, but perhaps we still have time for one question. Professor Stanisław Wicherek, you may ask your question. Yes, I have a provocative question. We have two women from France here in the room. They did not ask me to tell you that, but I have a question. Why do people think that French people live for a long time? So life expectancy for French women is very high. For French men is also quite high. The French government say it is thanks to our diet, thanks to our food, thanks to our health care. So sorry to the ladies for speaking on their behalf. They didn't ask me to, but, well, what's your opinion on that? I guess you are referring to the fact that there is red wine which is consumed in great amounts in France. There is a theory that longevity of French population is guaranteed by consuming red wine. Yes, there is a theory like that. I don't share this view, actually. I would say that France is a country which follows mostly the Mediterranean diets. And we have plenty of studies about that Lyon study, like a milestone in studies on diets. So plenty of studies about that in France. And then I would say that psychological factors in French population, well, I can suspect that, but I guess that these factors will play a significant role. That's what I have to say about that. But yes, it is true that France has great results. Longevity, yes, looks impressive there. I'm not comparing France with like Andorra or population Sardinia, but France as a big country is definitely at France. Oh, all right. So my point is we know where to plan our retirement years. So we have to. All right. So I guess we need young people if we want to see progress in medicine. We need a generational change. And so let me invite Professor Rafał Ryguła. He's going to discuss certain mechanisms connected with prevention, namely resulting from the new media, who believes in fake news, cognitive mechanisms, and personality traits associated with various phenotypes of susceptibility to disinformation. That's the title of his presentation. Let me just say that, for example, when we talk about vaccination campaign, you didn't have to be super clever to notice headlines on the internet that talked about side effects, problems connected with vaccinations. So it is a very interesting topic. The floor is yours.
Dziękuję bardzo za zaproszenie tutaj. To naprawdę wielki zaszczyt. Jestem też trochę onieśmielony tym, że zdecydowaliście się Państwo zostać tak długo, żeby posłuchać tego, co mam do powiedzenia. A będę dzisiaj opowiadał o tym, kto wierzy w fake newsy, jak już pan profesor powiedział, i o mechanizmach poznawczych i cechach osobowości związanych z różnymi fenotypami podatności na dezinformację, czyli o tym... Czyli o tym, czym zajmujemy się w pracowni Neurobiologii Emocji, procesów poznawczych, którą kieruję przy Instytucie Farmakologii imienia Jerzego Maja Polskiej Akademii Nauk tutaj w Krakowie. Zanim zacznę, chciałbym na chwileczkę przywołać tutaj jednego z największych myślicieli znanych ludzkości, Sokratesa, który kiedyś powiedział, że początek mądrości to zdefiniowanie pojęć i pozwolicie Państwo, że w skrócie zdefiniujemy sobie tutaj pewne pojęcia. Ja też pozwolę sobie na kilka słów wprowadzenia w temat, który pozwolą nam się rozgościć, umościć, zagnieździć w temacie i razem jakoś przetrwać te 20 czy 25 minut. Oczywiście wszyscy tutaj wiemy, czym są fake newsy. Fake news to słowo roku 2017 według praktycznie wszystkich prominentnych słowników znanych ludzkości.
During our prominent journals and according to the encyclopedia, is untrue or partially untrue message or information also of sensational nature published in the mass media in order to mislead readers for political, financial, or prestige-related benefits. It's often called information disorder, hoax news, pseudo-news, alternative fact, bullshit, but doesn't make sense to translate all that once we have fake news used commonly in Polish. And then we have a typology of information disruptions. So there are three different types of the disruption. So we have disinformation. So that is content which is verifiable, false, and promoted in a bad intention. So, for example, refugees from Ukraine come to Poland driving luxurious cars, and this is why they do not deserve to be helped. Then we have misinformation, which is the content which is falsely verified, but not necessarily promoted in bad intention. So, for example, taking a lot of C vitamin may protect us against cancer. And we have malinformation. So this is a promotion on verifiably true content, which is spread in bad intention. So, for example, disclosing sexual orientation of a political rival before the elections. Fake news and disinformation is nothing new. It was 44 before our era, before Christ. Octavian's propaganda campaign was using slogans that could be today published on our Twitter, and they were minted. They were it was published on coins. So much effort to spread fake news. And actually, I took the liberty to collect several of the slogans against Mark Antony. Let me quote: the career of Mark Antony started from him being an ordinary whore of a rich and influential Korean. Antony is an adulterer with no restraint in his bad conquest. Antony is a notorious drunkard, incapable of exercising power, unable even to stop himself from vomiting in public spaces. Octavian was surprised that these slogans met with no major response. Antony's soldiers were mostly receiving these coins, and they appreciated the fact that Antony was a notorious drunkard or adulterer. So at the next stage, Octavian, with Cicero, who assisted him, resorted to patriotic slogans, writing, Antony abandoned all the traditions of his ancestors and imitated foreign and barbarous customs, not worshipping the Lord gods of his father. Antony is a traitor. He is no longer a Roman. He is rather an Egyptian. He pays homage to Cleopatra, to a maid, as he were some Isis of Cyrene. It's surprising that 2,000 years later, the repertoire of political rivals remains basically identical. And some believe that the oldest documented, well, actually set in stone fake news, well, look at the form of and the effort put in spreading that fake news, dates back to the year 13,000 or 1299 before our era, and it's about unresolved, undecided battle that Pharaoh Ramses II had with Hittites, the Kadesh battle in Syria, where the Pharaoh presented the battle as his victory, but the battle did not end in his victory. And then we have Pasquillo, a literary work of an anonymous directed against a specific person, ridiculing him or her in a slanderous and abusive manner. And the name derives from a statue in the Roman Piazza di Pasquino, called Pasquino, which was used for centuries as a board to affix malicious comments. And because it was not far from the main track of the procession, so the impact of the pasquillos was huge. And the breakthrough came in 1450 with the invention of the printing press by Jan Gutenberg. And let me remind you that history of fake news went through 4 stages. So it was before print, when the effort in spreading the information was huge. Then the era of after inventing print, and then the new media, and then since 2015 we've entered the social media era. A great example of fake news of the printed era was the series of 6 articles published in 1835 by the Sun newspaper in New York about the discovering of life on the moon, claiming to recount discoveries of an astronomer, Sir John Herschel. So he was supposed to use a huge telescope, and the articles described in detail with drawings on the slide various forms of life on the moon: bisons, goats, unicorns, bipedal, tailless beavers, and bat-like winged humanoids. So humanoids, and actually a Latin name was invented for them, Vespetio Homo, that built temples. They were supposed to be forests, oceans, beaches, and falls. And these discoveries were allegedly made with the help of this huge telescope. And another example, dating back to 1950, the most popular British newspapers, the Times and the Daily Mail, printed articles claiming that the British naval blockades led to such a shortage of goods in Germany that German forces were using the corpses of their own soldiers to produce fat, bone meal, and pig food. This fake news was immediately demented, but it had far-reaching consequences during the Second World War, when the first reports of the atrocities of the Holocaust emerged. The people who remembered the articles going back to 1917, that led to doubts about the veracity of the information. So the era of traditional mass media started in 1933. So that was the Ministry of the Public Enlightenment and Propaganda, Third Reich, to spread hatred against the Jews using the then state-of-the-art media, radio and cinema. So the traditional media were so effective that the atrocities committed by the Nazis were committed with the widespread support of the German nation. And the Holocaust is being denied until today, and it's 21st century. So the history of fake news is long and rich, and false information campaigns of disinformation accompanied humankind from the outset. However, the term took on a whole new meaning during the 2016 US presidential elections and during the Brexit referendum in the UK, when it came to mean false or highly misleading political news, mainly originating from the social media like Twitter or Facebook. And the growing popularity of social media and the almost unfettered ability of its users to share content has meant that fake news has begun to spread unchecked by anyone, and that poses a global threat for the social order. In 2020, as we heard, brought another escalation in the form of widely spread disinformation about COVID-19 pandemic and information about the vaccination. And early this year, we had a festival of fake news about the war in Ukraine, which continues. On March the 3rd this year, the Institute for Internet and Social Media Research published the following message. In the last 24 years, more than 120,000 attempts of disinformation were reported in the Polish social media. Hashtag Ukraine, hashtag war, hashtag Russia. Imagine just 24 hours, one topic, 120,000 of attempts. Okay, so is there in this human psychology and its interactions with social media, which makes it for us so difficult to distinguish between truth and false, and that we become carriers of misinformation? This is a theoretical question. But let me speak about the factors affecting assessment of veracity of information. So first, we have the actual, factual veracity of information, or objective veracity of information, the post-truth era. So perhaps we should be saying about verifiable news. And then the second factor is cognitive usefulness of information, so that it can enhance our feeling of understanding of the world that surrounds us, and highly cognitive use of information is consistent with the recipient's understanding, and then vice versa, information of low cognitive usefulness is inconsistent with our views about the world, and basically aggravate the feeling of misunderstanding of the world. And then the style of presentation. The style of presentation could be populistic, reliable, and then we may have various effective load contained in the information. Well, they could cause shock, they could trigger shock or fear, anxiety, anger, and this way push us or to respond or influence our assessment of the information. The same refers to a social consensus. Well, we refer to as everybody knows, according to many sources. And according to our research, it seems that the most reliable is information which is verifiable, true, coherent with the assessing person's views and presented in a reliable manner. Well, here you will see that the average assessment of veracity is higher for in the information which is verifiably true than verifiably false, for these which are consistent, coherent with the life views of the assessor. And here, surprisingly, here we compare these three factors. So assessment of information veracity is predominantly affected by a verifiable nature of information, while the other two are also important. Apart from the ability to distinguish true from false, sensitivity to fake news is also dependent on the susceptibility to behavioral engagement in the incoming information. So what do we do with the information that we get? We can read it, we can just live it, or we can get engaged. So in the pre-internet era, we used to gossip. There would be some rumors, we would transmit them, we would transfer them further, but in the social media era, we have the repertoire of three behaviors which we can use on the internet. So we can like something, we can share something, or we can comment something. Three very simple reactions. It seems that the behavioral engagement in information is not dependent on the information veracity, but on their coherence with their cohesion with the life views of the assessor or evaluator. So it seems that the average of engagement is higher for the information which is verifiably false and true, and is much higher for the information which is consistent with the life views of the engaging party. And again, reliability plays a major role. Information which is reliably presented is attract more attention. So, cognitive usefulness of information plays a very big role, true role. And that is much above veracity and the style of presentation. So that shows that people largely focus on the veracity of information. When engaging in information, they focus on the information which is consistent with their views. So that may explain why false, fake news spread faster in social news than true news. So MIT proved that fake news spread 6 times faster than untrue information. And on the basis of the information, we propose that fake news spread as a Trojan horse. So we have a carrier of information and the proper disinformation. So the carrier would be of the disinformation is that it's something consistent with overall social view, and the information is consistent with the views of 50% of society, and the information is widely spread, and they tag that proper disinformation along. So we have many examples of fake news which is constructed like that. So for example, SARS-CoV virus was invented in Ukrainian labs, or the Ukrainian president Zelensky is a cousin of George Soros. George Soros is considered an enemy by conservatives. So this is the carrier of misinformation, and the proper disinformation is Zelensky. By connecting Zelensky to Soros, we get the right effect. So those who are not interested in Ukrainian war, they will be spreading that information in their information bubbles. So let me move away from the information, and I would like to tell you about phenotypes of susceptibility to disinformation, because susceptibility to fake news should not be verified alone. We suggested 4 different phenotypes, which is based on the susceptibility to fake news and true information, and their name would be gullibles. So these phenotypes are gullibles, consumers, doubting, and those who know. So gullibles are susceptible to fake news, are not susceptible to truth. They have very low opinion, they have very low opinion on the veracity of information, true information which they get, and they're highly engaged in fake news, and they do not engage very much into true information. And their opposites are those who know, who are not susceptible to fake news and are susceptible to truth. They do not engage in fake news. Then we have those who doubt, the doubting. They do not engage, they do not appreciate the truth or fake news. And then we have consumers who are susceptible to fake news, susceptible to truth. They engaged in all information, true or false. It turns out that the phenotype of susceptibility to disinformation may depend and may be different in terms of certain psychological features and cognitive processes. So when there is an assessment of veracity, the difference was observed in such features like feeling of superiority, vanity, the feeling of being privileged, authoritarian style, and grandiose narcissism, and anxiety, and being short-tempered, and susceptibility to awards. And then we also observed some differences in conciliatory nature, emotional stability, extravertism, and sensitivity to positive feedback, sensitivity to negative feedback, cognitive flexibility, bias, about being biased, and about optimism. So I took, together with my employees, I took the liberty to create psychological profiles related to the phenotypes. So those who doubt, they're full of anxiety, neurotic, and pessimistic. And besides, they are less narcissistic and less short-tempered. Then those who know, they feel anxiety, but they have positive, optimist trend in assessment, and their lower conciliatory nature is probably responsible for being more critical towards fake news. And those who are gullible, they are not anxious, but they demonstrate a pessimistic trends in assessing. They're highly conciliatory, and that increases their probability of engaging in fake news. And consumers are highly motivated, authoritarian, narcissistic, and vain. And they are characterized by the feeling of superiority and emotional stability. So these differences at the neurochemical level in brain, so at the level of brain neurochemistry, all the above mentioned cognitive functions and psychological traits are modulated by serotogenic neurotransmission. And because serotonin rules social behavior, at the next stage, and that is linked to the social behavior. In the further study, we tested the effect of chronic administration of the antidepressant drug from the selective serotonin reuptake inhibitor family, sertraline, or susceptibility to information. So it seems that, as you can see, we're analyzing the impact of 4 different doses and control, and we didn't see any differences in assessing the veracity of false and true news. But it turned out that sertraline modulate behavioral engagement in information. So what we do about the information, so those who are receiving sertraline, they were more susceptible to interact with information and share information irrespective of the veracity. And that was related to 1 dose of used chronically. So we could see that these people engaged both in fake news and true information. And here we also pooled all the doses. And here we have the major outcome of the drug. Those who take sertraline are more prone to engage in the information that they receive, and that might be connected with anti-anxiety, increased level of sertraline. Although we are still in the process of verifying the information, I've reached the end of my presentation. I think everyone is tired after this long day. So let me just recap briefly that fake news has been with us since the dawn of time, and they are here to stay, most likely. And their form of spreading has not changed very much. Most reliable information considered to be objectively true, consistent with our views, and presented fairly. Behavioral engagement with information does not depend on the truthfulness, but its consistency with the evaluator's worldview. So it all depends on the consistency of information, and it converges with our views. Fake news spreads like a Trojan horse. So as I was showing, well, that there should be a carrier and information proper, and the susceptibility to fake news should be studied in the context of general susceptibility to information, including truthful information. Phenotypes of susceptibility to the information differ in several psychological characteristics and cognitive processes, and the pharmacological intervention serotonergic system activity can modulate behavior engagement with information. I thank you very much for your information. If you have a question, do contact me, and let me also mention the project. And the name of the project is #webimmunization. So it's about building immunity to fake information. So we have this project together in collaboration with the Oslo University, Jagiellonian University, and other universities. Do follow us, because things are becoming more and more interesting. But now, actually, at 5 p.m., I was supposed to be at the kindergarten because my daughter has her kindergarten admission ceremony. So if you don't mind, I'll be saying goodbye. And I'm gone. Thank you.
Events in the lives of our children are very important, so you can go. Obviously, I will comment on what you have said. This image, this picture is not actually optimistic, because if you are cohesive in your concept, it is very difficult to change your concept or to accommodate, or if it wasn't that difficult. Well, so basically this presentation was not very optimistic in a way, because if you have solid opinions on politics, you will not modify them anyway, whether under influence of facts or fake news. It is quite interesting that it has something to do with neurotransmitters. Now let me say thank you to all of you. There will be no questions, unfortunately, to this presentation, but thank you to all of you, all the participants, for active participation, for persistence. We're trying to plan the agenda in such a way as to have the lightest topics towards the end. I'm not sure whether we have been successful in that.
Proszę Państwa, nie mogę...
Ladies and gentlemen, Jerzy Śmiałowski. I can't ask a question to the speaker because the speaker has left. It can't be done like that. You can't treat science like that.
Pytań, na które...
Either you have a paper, either you have a presentation and then you stay to listen to questions, or you don't deliver your paper, you don't deliver your lecture. You just stay if you have delivered a lecture. I had several questions because there were several notions introduced by the speaker, but the speaker has not stayed with us.
Uprawiać nie można, bo to jest niepoważne.
So it is not a serious approach to science. I would say it is like ignoring the audience. It is disregard to the audience. What does it mean, an important event elsewhere? I wanted to say that out loud because science requires reflection. And reflection means questions. Questions either confirm or undermine certain theses of the paper. So if you treat it... Well, I don't know the speaker personally, and I haven't met the speaker personally. Even though I've been a sociologist to some extent, it may be a bitter remark, but science is bitter. We have to swallow bitter pills. We suffocate on these bitter pills. We throw them up. And once again, we start our work. Or we leave it all behind, forget about science because it is useless, it is inappropriate, and so on and so forth. So we should think it over. How we approach science and how we respect those who have questions to us. I'm retired now, but when I was a lecturer at Jagiellonian University, I always answered all the questions of my students. Actually, the moderator was not on time, so perhaps we have to criticize the moderator for not being on time. So yes, perhaps that's what needed to be said. In science, there is no breaks in discussions. If a discussion requires it, you have to stay overnight. You have to carry on the discussion. If there is no problem, well, there are doubts. And our doubts can be translated into science. People paid with their lives for doing science. So that's my approach to science. What is the truth? That's another question. It is the basic question for science. What is the truth? I wanted to ask this question to the speaker because he needs to have some answers, how he understands the truth. It is not a simple matter. So that's all from me. Thank you very much. It was very interesting to listen to your remark. I do apologize for that. Well, it was out of our control, but I have technical information. If there are people in the room who wanted to see the Czartoryskis Museum, it can't happen today. because actually it was closed now, so you can't go to the Czartoryskis Museum. It's too late today. We will try to organize a trip tomorrow, so we'll have announcement about that tomorrow. Paradoxically, now we have too much time.
Musimy poczekać na powrót tych osób, które są.
We have to wait for people coming back from the Czartoryskis Museum, and refreshments will be served around 8:30. So I have a suggestion. Please remember your ID badges. Take them with you. I do apologize for this small mishap. Thank you very much indeed for this housekeeping information. For all those of you who learned something during this session, thank you. Have a nice evening.
Przekształcenia Zasłużonego Towarzystwa Naukowego Krakowskiego w Akademię Umiejętności. Dzisiaj to Polska Akademia Umiejętności, instytucja zajmująca znaczące miejsce w nauce krajowej i światowej. Piękny jubileusz 150-lecia pragniemy uczcić poprzez organizację Międzynarodowej Konferencji Naukowej pod tytułem Świat w obliczu nowych wyzwań. Wezmą w niej udział osoby cieszące się najwyższym autorytetem w różnych dziedzinach nauki. Ich wystąpienia będą poświęcone najnowszym osiągnięciom naukowym w różnych dziedzinach, które powinny się złożyć na diagnozę stanu ludzkości i świata, a także na pewne propozycje, jak rozwiązać problemy, z którymi się na co dzień spotykamy. Pandemia COVID-2019 nie była pierwszą tego rodzaju plagą, która dotknęła ludzkość. Wręcz przeciwnie, w średniowieczu i w czasach nowożytnych periodycznie powtarzały się epidemie różnego rodzaju, które powodowały ogromne straty w ludności, ale przynosiły też znaczne zmiany w stosunkach społecznych, także w kulturze. Tej problematyce będzie poświęcony panel pod tytułem Pandemia a kultura. Wezmą w nim udział wybitni uczeni, m.in. profesorowie Maria Poprzęcka, Dariusz Czaja i Piotr Krasny. Ich referaty powinny nam ułatwić zrozumienie, w jaki sposób pandemia, którą właśnie przeżyliśmy, a może dalej przeżywamy, wpłynie na rozwój kultury współczesnej. Zapraszam do udziału w obradach tej sekcji, które będą również transmitowane poprzez media społecznościowe.
Szanowni Państwo, tematem konferencji jest świat w obliczu nowych wyzwań. Niewątpliwie jednym z największych wyzwań, jakie w tej chwili stoją przed nami, to zrozumienie czwartej rewolucji technologicznej. Po wieku pary, elektryczności, komputerów przyszła era analizowania wielkiej ilości zbiorów danych. Wiadomo jest, że może sobie z tym poradzić jedynie sztuczna inteligencja, a być może nawet komputery kwantowe. Nasza sesja jest poświęcona dokładnie temu zagadnieniu. Przedstawimy zagrożenia, oczekiwania, nadzieje związane właśnie ze sztuczną inteligencją, z rzeczywistością rozszerzoną, rzeczywistością wirtualną. Na naszą sesję zaprosiliśmy znakomitych specjalistów w dziedzinie sztucznej inteligencji i interakcji nas ze światem cyfrowym. Serdecznie Państwa zapraszam na tę sesję. Dowiedzą się Państwo wielu różnych ciekawych rzeczy, między innymi tego, czy sztuczna inteligencja potrafi Was zwolnić z pracy, albo czy sztuczna inteligencja potrafi w jakiś sposób na przykład uratować Wasze życie.